Australia-India grant. So there's a number of people here that were students. So they now have doctor in front of their name because they've actually graduated. And Dr. Rao was a collaborator. I think he's since retired. This work was a few years old. So part of the concept here is, as I mentioned before, if you take fish oil and produce pharmaceutical products from it, then you're going to run out of fish oil and you start to have to use algal sources, which is now a big area. And one reason is because you get a very low yield, and making these high concentrates is actually very expensive and low yielding. And the pharmaceutical product is 85% omega-3, so you have to concentrate. They concentrate from fish oil. So there's companies like BASF, large industrial companies that have significant pharmaceutical divisions are interested in this area, and this is just a quote from BASF when they actually purchased Pronova that had the pharmaceutical product, interested in these concentrates. So if you have to concentrate omega-3s, you actually have to hydrolyze normally off the EPA, DHA, and other fatty acids, and then separate them and use fractional distillation, urea concentration, and other methods, and then you re-esterify them, which is a very time-consuming process. But if you can use an enzyme, you can potentially just remove the omega-3 or remove the shorter chain fatty acids and then separate the glycerols from the free fatty acids. And that can be done using a simple wash. So we were very interested in that process, and we developed a paranitrophenol assay to be able to screen the lipases. We also developed a fluorescent assay, and this is useful if you're looking at sort of fungal or algal and new lipases, because you can screen these at very low concentrations. So we found when we screen through, not only you can look for lipases, but you can take existing lipases and look at their selectivity. We found that depending on the active site of the lipase, we had different selectivities, and they were useful for trying to separate omega-3 from other fatty acids using lipases. So this paranitrophenol assay shows you, one way of screening, but you have to actually test it on the oil. So we actually took oil, we took the lipases, in this case, it's a commercial lipase, and we hydrolyzed. And in the bar graph, you can see here, DHA purple line is the DHA remains primarily on the glycerol, whereas the blue line in the C16, the shorter chains come off. So this is a way that you can potentially separate the omega-3 from the shorter chain fatty acids. And you can also apply it to separate EPA and DHA from each other. And this is maybe not easy to work out, but if you look at the top two bars, you see the bottom one, this is starting with fish oil, which is 1812. The EPA at the top starts to concentrate as you remove shorter chain fats, but then it starts to decrease as it starts to be removed, whereas the DHA continues to increase. So you can actually concentrate EPA, DHA, and then separate them using these lipases. And you can look at positional separation versus fatty acid separation. I won't talk about this. It's probably beyond the area of interest for most people here. And then you can screen a whole bunch of different lipases. Pancreatic lipase, we actually filed a patent on this because we showed that we could separate DPA from other fatty acids. And DPA is actually the main omega-3 in meat, like pork and lamb, for example. So that's a significant part in Australia, in particular, of the diet. Then we applied this to a range of other oils just to see how we could produce structured lipids. So emu oil's anti-inflammatory oil, but it doesn't contain EPA. So we thought, let's add EPA into emu oil. So we partially hydrolyzed off the saturated fatty acids with one enzyme, and then essentially added on the EPA with another enzyme. So this is carbon 13 NMR. You don't need to worry too much about this data, but essentially it shows that we're adding on, we can add on this, there's 3 positions in the glycerol. We can remove from any of those positions, and the 1 and 3 are different from the 2, and we can selectively add to the 1 and 3, or we can add to the 2. So this is that data here. So here's this enzyme T-lim and RMIM, they both add EPA to 1 and 3, but only one of them adds, the EPA to the 2 position. So if you use T-lim, you can add EPA, then you could potentially add another fatty acid to make a structured lipid and using a different enzyme. And another area, we had a couple of students who were on leave from their organization in China. They did a PhD with me. And so they were working in Palm Oil Institute, which is now Coconut Oil Institute. And they were very keen to try and apply lipase to make a healthier palm oil. So again, we did the same sort of thing. We remove the shorter chain fatty acids and you add either ALA, which is a short chain omega-3, or EPA, which is a long chain omega-3, into that oil. And that works quite well. And we got the food and function. We made a picture for the cover, which they accepted. Sort of representative of the research in an artistic way, I guess. So I'll talk a little bit, I think I'll just talk a little bit about applying these enzymes. And these enzymes can be obtained from they're mostly from microorganisms. So if you can find a new enzyme, then this is particularly a valuable area. So we're interested more in applying the enzymes now than we are, because it's quite challenging to screen and isolate the new enzymes, and especially if you're trying to use them commercially, then there's a regulatory approval process. But that would be an area that I'd be very interested in working with somebody on. There's nice metabolic engineering ways of doing this rather than just sort of screening. So anyway, but we were applying these enzymes. So one area was to make antioxidants, and there's hydroxytyrosol is a very interesting compound. It's a waste product from olive pumice, but it's actually a commercial ingredient. So we're working with a company which is the biggest olive oil producer in Australia to look for what we could do with hydroxytyrosol. And we decided to add fatty acids onto it, plus some other compounds to make antioxidants for stabilizing oil. So here's where we applied our lipase to essentially add fatty acids, different fatty acids, to make what we're calling conjugates. So it's adding a fatty acid onto the hydroxy group on this hydroxytyrosol. This is now oil soluble, so then you can use it to stabilize omega-3s. And we tested that. This is something called ransomat. It's just a way of rapid testing of oxidative stability. We showed that hydroxytyrosol EPA actually stabilized the oil more than some of the commercial antioxidants. And we screened through a range of different fatty acid derivatives. The EPA version is actually a better antioxidant than, for example, palmitate, which is a standard type of derivative. Then we want to show that it worked in emulsions and bulk oil, which is what these graphs do. Essentially, if you want to apply these antioxidants, they have to be able to work in emulsion systems and they have to be able to work in oil systems. This is really just showing the storage stability of these. We're doing this in conjunction with a company in Australia that's a US-based company, but they have a subsidiary in Australia called Chemin. Their main business is antioxidants. So then what we also do, we want to apply microencapsulation to stabilize further. So we have a technology for microencapsulation, which I'll probably describe, but in this case, we just test everything in our microcaps. And microcaps is useful because it's actually a way of delivering these oils into food. So we did the same thing with vitamin C, ascorbic acid, made a ascorbyl EPA, which was also a very good antioxidant. And then here's just showing you can make these in very large scale. This is just obviously small scale, but you still get very high yields and very easy to separate. It's quite useful commercially. And then we tested again the ability of these conjugates to stabilize, in this case, tuna oil, and the ascorbyl EPA and other fatty acids were very good, but the EPA was in particular a very good antioxidant. So I think I'll just do one last component, which is again related to lipases. And I know that, you know, this is a little bit outside fungal biotechnology, but if I'm a lot of these, like I said, anything that any organism, including fungi, that can produce oils and omega-3s in particular, can produce lipases, and those lipases have commercial utility. So we're interested in that. But what we've done here is we've taken existing lipase, and instead of finding a new lipase that has a function, we've tried to modify the function of the lipase using surface immobilization on a nanoparticle. And we chose graphene because we do work on graphene, but also we can control the surface of graphene. And actually, if you want to use a lipase commercially, and you want to use it 50 or 100 times, you normally have an immobilized version. So you can actually just isolate the lipase out after you've done your reaction, or you can make a lipase immobilized bed and flow your reaction through. So it's very common to use immobilized lipases. And when you immobilize a lipase, it can change the function of the lipase. So we try to control this process. So essentially, you can hydrophobically bind the lipase onto the graphene surface. And you can control the surface of the graphene depending on the level of oxidation. So you basically make graphene oxide and then reduce back to various levels of oxidation, and that changes the hydrophobicity of the surface. So then you immobilize on those different surfaces, and then we use electron microscope to show that we had immobilized it, plus obviously other methods which I won't go into, but you can use atomic force microscopy to show that there's an increase in the size of the nanoparticle where the protein is binding. And the interesting result we found, actually, which we published in ACA Catalyst, which is a very nice journal, was that as we increased the hydrophobicity of the surface, we were actually increasing the activity of the lipase. And we actually showed later, which I won't talk about today, we changed its selectivity. And we did some modeling with IBM, and they showed essentially that as we increase the hydrophobicity, we're opening up the lid, because these enzymes have a lid that controls substrate entering. So we're increasing the binding of the lid and opening it up and making it more accessible, which explains the increase in activity. And you can see in just the B figure below, there's an angle between the lid and the rest of the protein, and that angle changes with hydrophobicity, and that's what the figure E shows, that angle is increasing as you're increasing hydrophobicity. So you're actually using a surface to control the function of the enzyme. Then we immobilized on commercial supports based on that graphene information that could then be used commercially. And then we can actually make a material that can be used in a flow-through system, which is called, we call it enzyme paper. It has lots of layers of graphene, very high loading of the enzyme, and then you flow through your solution to do your reaction. And I won't talk about the details, but we make that using a proprietary method that we have, and we've shown that the graphene paper, in a similar way to the graphene in solution, works the same. And I've done some stability on that as well, which I won't go into detail here. Okay, I'm not going to, I think what I'll do is I'll probably stop there because I know we're a fair way behind, and this is moving probably a little bit away from fungal biotechnology work.
Continue.
Oh, okay, well, I'll keep going then. So we're also very interested in stabilizing the material using microencapsulation for delivery into food and beverages. So a microencapsulation uses a process called complex co-activation, but what you're basically doing is you're taking an unstable oil like omega-3 and surrounding it with a protein shell so you can deliver it into food and not get oxidation. So we get these particles that are about, well, the ones we make are about 30 microns, and we get a payload of about 70 to 80% oil, and we get something that looks like flour. So you're essentially taking your oil and producing something that looks like flour that can then be incorporated into products. So it looks like this under the electron microscope. you've got quite a thick shell, and that essentially helps prevent oxygen getting in. And then we can test the stability improvement using a method that I mentioned before, using equipment called a ransom map. And essentially, as the length of your plateaued, region here in hours increases to where, so you go to where those arrows are, that's when it starts to oxidize and you see increase in conductivity. So that the length, you're trying to extend the length of that non-oxidative phase. And the other thing we wanted to do was to determine the payload of the oil. We didn't want to have to grind up the oil and measure the oil every time, grind up the powder. So we developed a method using FTIR, where we could basically just run FTIR directly on the particle. And actually, we extended this method, and I should have probably talked about this, to the synchrotron, which we have in Victoria. It means you can do very high resolution. And we actually took live thruster chytrid cells, which we published on now, in the synchrotron, and we showed that we could measure the amount of EPA and DHA in the live cells in real time. So I should have actually probably included that. It's probably more relevant than some of this, but that's a very nice method. Obviously, you could do the same thing with fungal cells. So if you're looking at growth, and it wouldn't have to be applied to, the advantage of the synchrotron is you can go to very high resolution. So you're using FTIR or Raman or some spectroscopic method, but you're doing it on a cell scale. So the synchrotron, you can look at an individual cell. So you could look at any material that you could look at by FTIR or Raman. And we were not just looking at oil, we're looking at EPA and DHA. So it's a very nice method in terms of analysis of live cells in real time. But here we're applying it to our microcaps, and not the synchrotron, but just the FTIR version. And you can see the protein, you can see the oil, and you can see the microcaps, and you have to do a second derivative of spectrum. And then you can actually deconvolute it so you can determine what the amount of oil present is. And you can start to look, as I said, for signals related specifically to omega-3, EPA and DHA, and then determine that in these microcaps. And the microcaps are 30 microns, so you could do a similar thing in live cells, as I mentioned. Then we did co-encapsulation, tuna oil and probiotics. So we actually put live cells into our microcaps. Obviously, cell size is a lot smaller than the microcap size. And we showed that this is quite an interesting result. We published this with the probiotics, because one of the issues, if you want to put probiotics into food or beverages in particular, is that they don't live that long necessarily. So if you can put your cells into something where there's food for the cells, and in this case, the oil, they actually survive a long time. So you've got a double benefit here. You've got the microcap itself, stabilizing them and keeping them away from whatever oxidants or things are in the liquid beverage environment. Plus you've got a food source for them, in this case, oil. And they had very good survivability. And then we added other things into the oil, just to like CoQ10, curcumin and so forth, to show that we could co-encapsulate a range of ingredients. And again, I said, this has been published, so there's a couple of papers here. And we showed we could do this with concentrates. I won't worry too much about that, but we basically improved the technology, and that's what this publication is. And then now what we've been doing recently is trying to improve what's called the cross-linking process. So to stop these things falling apart, you have to cross-link the protein matrix. And we've shown that we can do this with seaweed phenolics. And you can do it, there's a range of ways you can do it, but seaweed phenolics is quite a good way, and we're working with a company on that. And they're also working with Reddy, which is the biggest aquaculture feed supplier in Australia, to encapsulate astaxanthin, because astaxanthin at the moment in aquafeed, it's sprayed on the outside of the feed, and it's actually a very expensive ingredient and it degrades quite rapidly. So we're putting it inside the feed directly because it's a colorant in salmon. So salmon aquaculture requires astaxanthin. So we've actually shown that we can put it into our microcaps, and you can see on the left-hand side, there's jars or bottles with the microcap in it. So we've done that where we sprayed right it, and we're currently doing feeding trials of the astaxanthin. And then just coming back to the thruster chytrid oil. So we've sort of come full circle where we've taken our thruster chytrid cells culture, and then we've produced a dried biomass from it. And then we've produced oil and astaxanthin in the same fermentation run. It's because salmon requires omega-3, plus it requires astaxanthin. So we've combined that into our microcap and then added that into the aquaculture feed. And this is just going through that. And I think this, again, emulsion work, I will finish here, Sunil. So thank you for your attention. And I know not all of this is fungal biotechnology, but hopefully you can see how some of this work can be applied to fungal components, because one of the usefulnesses for me around fungi or any of these microorganisms is using them as factories for the production of materials. And then some of this work is extension of the use of those materials. So let's see if I can stop sharing, and I'm happy to take questions.
Dr. Mulani. Hello.
Yes, sir. Yes, sir. Sir, Amruta, you can start.
Thank you very much, sir. Thank you for your extraordinary work in biodiesel, fungal biotechnology, and in clean and green energy for future. Thank you for your talk. Well, being someone had said that the aim of education is the knowledge, not a fact, but a practice. It is on the occasions like this we gain opportunities to taste our knowledge and understandings. We look forward to get an exposure about what the base of the brains think about this very dynamic areas in biofuel, especially in fungal biotechnology. Now, moving for the next technical session of this conference, ladies and gentlemen, may I now request Dr. Aryan Mulani sir to please introduce Professor C. Manoharacharya sir, who is a renowned mycologist from Nasi, Senior Scientist, Department of Botany, Osmania University, Hyderabad, to be a
Is there
chairman
no question
of
answers?
the first session.
Hello.
So, may I please
Sir,
Dr. Aryan Mulani to please introduce
questions
Dr. C. Manoharacharya.
Hello.
Yes, sir. We are taking questions.
Before starting the session, we are too late, so we'll have 2 to 3 questions for the calling gents participant. So, ladies and gentlemen, if you are having questions, you may ask, sir. Please unmute all the mics of delegates and participants. And
केलेलं ते करतील अनम्यूट केलेलं का आपण केलंय ना सर अनम्यूट होतंय ना ठीक आहे
Hello. Hi. Yes, sir. Yes, sir. This has been a wonderful lecture, and I congratulate the organizers and Dr. Deshmukh and the speaker from Deccan University. Really, it is very interesting. Number one question is that do you find thrustochitrid in fresh waters?
You can find them at the interface in brackish areas. So you can find them at the interface between the ocean and fresh water. They're classed as saltwater species, but that said, you can actually grow them. They tend to grow better in salt water, but you can grow them in the absence of salt. And there's actually a patent on that. So most of them have been collected in ocean environment, but I think there's potential to find related strains because they can be grown without salt in fresh water. But like I said, that's less common.
The second question is that you said that omega-3 oils are very rich in the case of thrustochitrids. But do you find that kind of situation in almost all thrustochitrids, or it is rare?
You mean carotenoids, did you say, or?
No, thrustochitrids. Do you find 3 omega oils in almost all thrustochitrids?
Yeah, most of the thrustochitrids, one of the things we did was compare India strains and Australian strains. And one thing we found is the warmer the water, the lower the omega-3 content in general. So most of them contain DHA and omega-6 DPA, but the ratios and amounts vary. So it's a matter of finding a good producer with a high level. So the best producers have around 30 or 40% DHA or up to. So there's a lot of strains have around 10%, which is not as commercially useful. So they do seem to contain omega-3, but they have different ratios and different levels. And one of the big efforts has been to try and find a natural strain that has higher levels of EPA, but nobody's found a strain that has more EPA than DHA. So there is some control over their fatty acid ratios.
Thank you very much. It is a wonderful lecture. Congratulations to you, to your group.
Thank you.
Yes, will anybody?
Thank you very much, sir. Thank you. Now, we are introduced Dr. Arna.
Hello, sir. My question is how this product, like, if I hypothesize that you,
Yes.
yeah, if I hypothesize that you market this product omega-3 fatty acid, then how it is different from products that are available right now?
Madam, speak loudly.
The quality of the
Product
sound.
omega-3 fatty acid, how your product omega-3 fatty acid is different from the products that are available right now in the market?
Yeah, so one of the advantages of microorganisms is you can potentially control ratios. So if you look at fish have a natural ratio of EPA and DHA. So it's difficult to modify that because it's often wild harvest of the fish material. So most of it comes from actually anchovy from South America, which has a ratio of about 18% EPA, 12% DHA. So if you want to have, say, infant formula where you only have DHA, then you have to separate the EPA and DHA, which is difficult. But if you can do it through fermentation, you could potentially, even though there's natural ratios in microorganisms, if you can do good metabolic engineering, then you can modify those ratios. So the future of production of these types of materials is through fermentation. I hope that answers the question.
So if there are no more questions, so I will thankful to Professor Colin Barrow for really accepting the invitation. It is always fun working with him. At least 3 students I have worked with him and they are all excited working with him. So thank you very much again, sir.
Thank you.
So you can proceed further, Dr. Molani.
Yes, sir. Thank you, sir. Thank you very much.
Now, may I please Dr. Arna?
Hello. 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 Hello.
Yes.
You can proceed for next speaker.
Can you hear me, sir? Deshmukh sir? Hello?
You.
Deshmukh sir, can you hear me?
Yes.
Hello? Achha. Sir, Mulani sir. Sir, Mulani sir, okay, you can come here from here. You can use this one. Laptop you can use. Just wait, sir.
Sir,
You can.
sir, now in this second session, we have as a lecture of Professor Dr. Krishnendu Acharya. He is from Kolkata, and for this session, the chairman is Professor C. Manorachari.
Yeah.
So Professor C. Manorachari, as everybody knows in the Indian mycology, is a great scientist, NASA senior scientist from Department of Botany, Usmania University, Hyderabad. He has been awarded Young Scientist Award in 2000. Then Dr. Shaligram Sinha Award in 2007. He was a president of MSI long back in 2008-9. He was awarded with Lifetime Achievement Award, and a very interesting research worker. Still continuously he is working in the field of mycology. He is an inspiration for all of us. It is a great pleasure for us to invite him as a chairman for this session, and I request Professor C. Manorachari sir to start the session and introduce Professor Dr. Krishnendu Acharya. Thank you.
Dr. Krishnendu Acharya is a professor from the Department of Botany, CAS Botany, Kolkata University, and West Bengal, Kolkata. He has been an active member of MSI and very renowned mycologist of this particular country. And he is also a fellow of West Bengal Academy of Sciences. His contributions in the form of research publications has been more than 120 research papers, and then guided a number of students. And a young researcher with a prominent role in Indian mycology. He has been working on the taxonomy, biodiversity, and biotechnology of fungi, and recently has taken up the organic agri entrepreneurship activities for sustainable agriculture, and very interesting personality. And without taking much of the time, I wish that his talk will be very interesting for the farming community, and as well as for the youngsters, and also for all the scientists who have gathered here. And Krishnendu Acharya is a very dynamic personality, served as head of the Department of CS in Botany, Kolkata, the oldest university, and which was established before the UGC formation. And may I request Dr. Krishnendu Acharya to proceed with your talk?
Sir, can you hear me?
Yeah. Please.
Yes.
Yes. Before entering into my talk, may I request all of the participants, please mute your gadget, okay? it's really disturbing when anybody talking. I just hear last that delegates who is speaking on this omega-3 fatty acid and all these things. It's really very much disturbing.
Dr.
So
Acharya, do it full screen.
yeah, I will. Yeah, right now it is full screen. Okay, is it
It's
okay?
okay.
Okay. So, respected,
Yes.
respected our beloved Professor Manojari sir, distinguished guests, delegates, members of the Mycological Society of India, faculty members, participants, ladies and gentlemen. First of all, I would like to thanks Dr. Desmukh ji, President of MSI Mumbai chapter, for his invitation and providing me this web platform where I can share my work. I am also very much thankful to the organizers. So, in this pandemic situation, many people loses their jobs. In this pandemic situation, people are looking for good food, which definitely also boost their immunity. Being a biologist, I have tried to open an avenue through which I can help them to become an entrepreneur and self-sustainable one, utilizing my little knowledge. So during last 1 year, more than 500 self-sustainable families were established in the rural West Bengal. Still, many are in queue. Today, I would like to share the glimpse of my journey where I have utilized my knowledge in mycology, plant pathology, microbiology, fermentation technology, biotechnology, economics, management, and marketing. So, my topic is on biotechnology based organic agri entrepreneurship model, a small step for better future. So all of us aware of the ill effects of inorganic cultivation. It's now not only actually destroying our environment, it invites so many killer diseases within us. And truly speaking, if we look carefully, every morning we went to market, purchase some poison, bring it to our house and feeding our family members. So in this situation, everybody is talking about, crying about good food and organic one. To whom we are going to involve in this journey? The farmer. And if you see carefully, most of the farmers are not getting proper return from their farming materials. And again, we are asking these poor farmers, go for organic and go for organic and go for organic. And we go for so many farmers meet and always asking them, please give input, carbon input in your crop field. So if the farmers ask this question, sir, can this compost, just utilization of compost can serve the purpose? We'll say no, you have to use some microbes which we have killed during the last 60 years by application of different types of chemical fertilizers and chemical pesticides every day from morning to evening. So you have to again return them back by supplementing your soil with azotobacter, PSB. You have to manage the PGPR. You have to manage your manage the crop diseases by application of trichoderma, pseudomonas, bacillus, Beauveria, metaherginium, bacillomyces, like these organisms. So again, if we ask them, if they ask us from where we'll get, we'll definitely show them that some industrialist will produce all these things, pack it for you, and they will sell that thing in the market. You will purchase and put just supplement your soil by these organisms. Those who are microbiologists right now in this seminar, please check the packets available in the markets and try to understand how much CFU is there. You will find, probably you will find many, only few numbers of CFU. And in many cases, you will find contamination of aspergillus and many more things. And when you are keeping these things in a talcum powder or in charcoal-based media, it's very difficult to keep them in a longer period and in a stressful condition. And after putting them in the stress, when you are releasing this organism in again a very stressful environment in the soil, do you think that organism will fight against all the means the poison presence in the soil? So again, there is a big question mark. So that way, we cannot serve the society with appropriate organic cultivation system, because whom we are going to serve, the people who actually converted their blood to sweat. Actually, we are sitting here in front of this computer or mobile because we have a full stomach. But in a AC room or in a very well ventilated room, but the farmers Bhagwan, they are right now in the field producing crops for us to fill our stomach. So in this scenario, I have tried to develop certain things for my farmers Bhagwan, to give them certain technology through which they can produce their crop in more scientific way. It is basically a story of a journey from lab to land and land to society. So truly speaking, a organic farming means, this is my model which I have developed, introduced in the farmers field. That is a complete package model. You have to provide a complete package model to the farmer so that farmers can utilize and produce all these things in their small kitchen, so they can transfer this thing into the field. So farmers are aware. So there is three distinct hands. One is soil quality and fertility management section. Another one is foliar organic nutrients nutrition section. So because we are most of the crops are hybrid, they need certain foliar nutrition for their optimum growth. And also another big section is the pest management section. So one by one, I'll clarify that thing, that a good compost. So generally they know how to prepare compost, but we always tell them, in your compost, try to add some wood ashes and also try to add banana stem part. So your compost will be enriched with the potash also, and also the micronutrient. And they now producing the enriched compost. Then they need beneficial microbes. They need growth promoters. They need a system through which they can prevent their disease. They need a suitable disease protection strategy and the marketing strategy too. So, all the farmers knows this particular part, that is the vermicompost, compost, and biogas slurry. But they also aware of all these things, that for good production of the crops, they need certain nitrogen fixing bacteria. They need some phosphate solubilizing bacteria. They need some phosphate solubilizing microorganisms. They need some PGPR, plant growth promoting rhizobacteria. So, all of us know what is the meaning of all these things. So we know the meaning of azotobacter. What is the importance? What are the importance of this azotobacter for organic cultivation system? Beside nitrogen fixation, this azotobacter also perform many more things which helps our plants to grow well. And azospirillum also a nitrogen fixing bacteria. There are lots of phosphate solubilizing bacteria and fungi available in the soil. So they have a tremendous role. Not only it's releasing the phosphate in a soluble form, but also they perform, they produce hormones, they produce hydrophores, they have produced antibiotics, antifungal metabolites, and also they can produce ACC deaminases, antioxidants, and many more things as a bonus, beside the major role that is the solubilization of phosphate. And also we know nowadays PGP are an important component for organic farming. So if your farmer asks you this question, from here we will get all these things in the market. Only up till now only few of them are available, but no all the cultures or all the products are available in the market. So we will tell them, definitely you go to the market and purchase this from the retail shop. So from there you will get it. But if the farmer asks you, can we produce this thing in our premises? You will say, yes, you can produce all these things. You have to purchase a biomass production unit, which is cost around 10 to 20 lakhs of mass production system. So so they will means they will tell, okay, so we'll go for purchasing this thing. So after keeping this all this material for 6 to 8 months in the packet, can this bacteria present in the packet make justice to the soil soil, or to the health of the soil, or to the health of the plants? So here I have tried to design an instrument for my farmers. Actually, that is a biomass production unit for the farmer, which is cost around within 10 to 20,000. This is my instrument I have designed for the farmers, and that farmers can produce these organisms in their kitchen. They don't need sophisticated laboratory for that. This is my instrument. This is a vessel, that is a fermentational vessel, where I can propagate the azotobacter, PSB, and all the bacteria, where we can propagate them. And we make some capsule for that. These are the media capsule. So cut a media, put here. So no need of so many degree for these things, and so many laboratory expertise for this. Just cut it, put it in the bottle, just put the water up to this level. Okay, there is a mark, so put water up to this level, and you just sterilize it in a autoclave. So again, it's that autoclave is around 35 lakhs, sorry, 35,000 of cost. So what we did, we just changed for autoclave into the big pressure cooker, that is 3,200 rupees. That the cost 35,000 goes down to 3,200 rupees. And within that pressure cooker, give the just heat it, fast city, then wait for 25 to 30 minutes, then take out the media. So after getting out the media, you have to inoculate the media with the appropriate organism in a laminar airflow. Again, laminar airflow cost around 60,000 rupees, a minimum cost, the Indian made cost. So again, I converted that 60,000 rupees into 60 rupees. Just take a dispo van, just 50 ml disco van, and I just make a big needle to draw the culture from the media. That culture will be supplied from the laboratory. Then they draw the culture and just injected it. So sterilize dispo van with a sterilized needle. Just draw the culture and just inject it and put it in the fermenter, that the biomass production unit, and just wait for 72 hours, and then they will get around 10 to the power 10 cells per ml. So this is a single batch of this type of fermentation produce the biomass, which can be the commercial product of 60 kg. Just think about that. That 60 kg commercial product, which have a very little number of viable cells or CFU in that product, here they are producing their organism in their small laboratory, small room, that is 6 feet by 8 feet room. They are utilizing for the production, and this one batch can provide 60 kg of the commercial product, which cost around 250 rupees per kg into 60 rupees is around 15,000 rupees, but they are producing at a cost of 600 rupees. So that 60 kg they are producing at a cost of 600 rupees, and the per kg is a cost of 10 rupees per kilo, and the viable number, and they know the birth certificate of the organism. They just produce it, immediately they transfer into the soil, so in their crop field. So that way they can produce these things. So I have designed a small instrument for my farmers friend, actually giving the service to the society. Then beside this, they need growth promoters. So I have designed another simple tool that is using the production of vermi wash. I just purchased a 200 liter of this thing, 200 liter this plastic means can. Then make different layers of this thing. This is a gravel layer. After that, soil and compost. Then after that, cow dung. Then the earthworm. Then again give cow dung. Then compost, and put water in form of sprinkler. And after you will get certain liquid will come out. So after 15 days, you will get a liquid like this one. And after 25 to 30 days, you will get a liquid of this type of liquid. And just see the composition of this vermi wash. So just get the vermi wash, and that vermi wash can be diluted into 10 ml per liter in a ratio of 10 to 20 ml per liter, and spray foliar application of this thing. Also supplement the plants with all these things. So it's a one-time investment and lifetime getting of all the important components for the better growth of the plants. Not only that, nowadays in market, that amino acids, they are actually spraying amino acid to the crop. So again, that cost of this 1 liter amino acid is around 1200 rupees. So 2 liter comes around 2400 rupees. But I make one simple technology. I use the fish, waste fish, and I just ferment it with jaggery. And they need an incubator, and you know the incubator is cost around more than 45,000 rupees. So I changed the incubator into 0 rupees. Just dig the soil, put your vial within that. So just 15-minute investment can save your 45,000 rupees. And put the fish, 1 kg of fish or 1 kg of soybean, 1 kg of soybean meal, and put 1 kg of jaggery, and just ferment it for 45 days. After that, you will get a black colored liquid, and keep it, just filter it, and no smell will be there. Just a beautiful black colored mix liquid will be there, and just keep it in the vial for and that can be utilized for next 6 months. And 5 to 10 ml of this preparation can serve the work for amino acid. So more or less 80 to 100 rupees is required to production of 2 liter of 2 liter of this fish amino acid. So 2,400 rupees again goes down to 100 rupees. Okay. So after doing all these things, also we are providing them the humic acids. That also helps the foliar application of humic acid, also causes so many benefits for the plants. Besides this, they need disease to be protected. So here we made 2-stage disease protection strategy. One is disease prevention strategy, through which they can prevent their diseases. So what we did, we just, in spite of pathogen, we just make the small molecules of some component of the pathogen, and that is in a nano form, that can be sprayed over the plant surface. So in spite of pathogen, that molecule, that elicitor molecule, as a botanist or a biologist, you know the elicitor molecule, actually sit over the surface of the plant, actually mimics the activity of the, the signal of the pathogen but no pathogen is there. So what the plant will do, they will boost up their immunity, and thereby they can protect themselves from the forthcoming pathogenic attack. So that is a new strategy for crop protection that we have developed, and we have utilizing this technology, that molecule binds to the receptor and do several function. Ultimately, it activates nitric oxide production. Also, it activates the, so they can go for HR, they can go for LAR. So enter into the adjacent cell where it will produce LAR, activate the PAL, activate cyclic acid pathway, and ultimately through nitric oxide production system. Also, they produce GSNO, that is the reservoir of nitric oxide, through which it's actually go through the phloem to the distal part of the plant, where it will produce SAR, systemic acquired resistance. Okay, so ultimately just giving a message of a pathogen. Here we have tried to give the message of the pathogen, not true pathogen. Thereby we are just boosting up the immunity of the innate immunity of the plant. Thereby that plant can protect themselves from the pathogenic threat. So that has been published in scientific reports earlier. We made chitosan-based nanoparticle, which is actually a positive modulator for the innate immune system in plants, which can reduce up to 80 to 90% of the pathogenic attack. So that has been reported by the Nature India group as an important work. So after that, actually, that has been translated to the field level. This is my product which I have developed for the farmer friends. So for farmer friends, just tell them, just don't go for producing all these things. When you are go for producing compost, use some shrimp shell or crab shell, dust it, or the big mushroom means fruit body dust within the compost. That will ultimately, the bacteria present within the compost, they actually converted into chitin to chitosan. So that can be also boost the immunity of the plant cells. Okay. So next one is the disease protection system. So for disease protection, there are several fungi, as you know that they are bioinsecticide. Beauveria bassiana is there. So I have a beautiful culture of Beauveria bassiana. So Beauveria bassiana, if they can cultivate it, they can easily control so many types of pests in the crop field. We have also Verticillium lacani. They are also producing Verticillium lacani. They are also producing Metaharginium. They are also producing Pilcilomyces linaceus, which controls the nematode in the field level. Not only that, for controlling of fungus, we know Trichoderma harzianum, Trichoderma viridi, Trichoderma asplenium. So I have given them technology through which they are producing Trichoderma viridi, Trichoderma asplenium, and they are producing all these things. You know the market price of all these products around 200 to 250 rupees per kilo. All of them are in talc-based formulation, but they are producing all these things per kg at a cost of 7 rupees. Remember my things. They are producing all these things at a cost of 7 rupees per kilo. So that way they can produce a live organism of all these things. Ultimately, the live organism, they directly transfer from their small 6 by 8 feet room to the field. So this is Pseudomonas. Also, they are producing, these bacteria also producing, Pseudomonas are there. Bacillus, different species of Bacillus is there. The Bacillus thuringiensis is also there. They are producing with the help of this fermenter. So beside this, we also given them many botanical based formulation. They can prepare it. So after completing all these things, generally we the scientists always tell the farmers or other people, I have done this thing, you test in your lab, in your field. But in my case, always I did all these things, then I test it by myself in field. That these are the example where I have tested all these things. This is in tea plant, in tea seedling, where just see the difference within 1.5 month change of the growth of the plants. And these are the different tea varieties I have tested. Also, I have tested in my own village, in my own land. that in rice cultivation system, where I have found that the improved growth of the things. This is my area where I have tested my material. My father don't believe that thing initially. He told me, I am giving you this small area. You just show me what you can do. So so after this is a 19 days old plant after transplantation. So this is during the flowering time. Just see the difference of the root. Just see the change in the growth of the this plantation material. This is conventional. This is my system of cultivation. 45 tiller per plant. Here they are getting 12 to 20 tiller per plant. And just see the single plant and the size of the panicle, and you just see the difference of the size of the panicle. This is 165 on per panicle. This is 185 on per panicle. After all these things, then I have translated this thing in a village that is Hooghly district, West Bengal, in Balaghar. This is the small laboratory I have developed for my farmers. And I brought them, I just talked to them, I brought them to my department. I have discussed with these young farmers then what to do and how to do. I have shown what organism we will transfer to the field. I have trained them how to prepare media in my laboratory. Just a single day workshop for my farmer, and highest qualification of these peoples are class 12 pass, and most of them having up to class 8 level school knowledge. Okay, so they, after seeing all these things, just see the smile space that of this farmer. So after doing all these things, now I establish a laboratory in the field. So these are my farmer scientists. They are doing all these things by themselves only. They are producing all sorts of organisms by themselves. So they are producing 8 different types of microbes here. They are producing the rice inoculation, rice grain inoculation for trichoderma, solid trichoderma production. They are producing the Pacillomyces. They are producing trichoderma. They are producing Bivaria, and they are, just see the liquid culture of trichoderma. Just see the growth of the trichoderma. So one bottle is enough for making 1 kg of powdered material, which is available in the market. So they are producing 1 kg of this product at a cost of only 7 rupees. Only 7 rupees. And I have not asked them to purchase the conical flask, which is cost around 175 rupees. I asked them to purchase this type of bottle. It is only 3 rupees per bottle. So, so the price of this bottle is only 3 rupees. So after they producing, also I have given a technology of pheromone trap. They use this pheromone trap for their field and trapping the fruit borer insects from the field. So that's now come to the example of certain achievement of this area. This is a crop field, open crop field, where they are producing rice, they are producing vegetable. Just see the growth and the color of the plants. Not a single molecule of chemical fertilizer, not a single bund of any chemical pesticide. So just see, these are the crop fields. They are doing all these things. This is in the Balaghar region at Hooghly district only. So here 30, my single that structure of my total model actually can feed 30 acre of land. 30 acre of land successfully round the year. So this is a potato field. So after that, I have made a strategy from lab to land and land to directly to the consumer. So I engaged 30 farmers for this particular cooperative system, and then I make a web-based system through which the people of the local area give order that I need this vegetable. So in the morning, they supply all these things in their doorstep. So So directly from the farmer's house to the consumer house. So that model I have also developed. This is actually a model for the open field crops cultivation system. This is another area where I have made the fruit orchard. This is a barren land, never cultivated any time before in Bankura lateritic soil. So there is nothing called NPK in the soil, where we have tried to introduce a fruit orchard organically. So this is the laboratory we have developed there. They are producing all these things in their laboratory, and just see the fruit orchard. That barren land of 10 acre now become a gold mine. They are earning 1 crore rupees turnover per year only. 1 crore rupees. They put all the exotic fruits crops there in their fruit orchard. So this is papaya, this is dragon fruit, this is the color of, you can see 35,000 of dragon fruits they are cultivated, and intercropping like seedless lemon is there. And this is, just see the color of dragon fruits, you know the health impact of this dragon fruit. Beside dragon fruit, they are also going for intercropping of tomato, this cabbage. Also, they are producing guava in their field. They are producing this Malta. These are the pomegranate, seedless lemon. This is Malta. Also, they are producing chili as an intercrop. And now that farmhouse becomes sustainable, and this is a medium scale industry I have tried to develop. Now that industry increased to 30 acres, 10 acres land to 90 acres of land. And and in that particular area land, 17 people got job to do all to sustain their family. So beside this, we translated this thing in a poly house. This is a 1 acre of poly house, where we have cultivating the English cucumber, also some vegetables along with that English cucumber, and that is in a poly house system. We try to incorporate totally organic cultivation, and it is a single plant giving more than 3 kg of English cucumber per cultivation season. Okay, so again another thing we have made it in Biharinath area in Bankura district. That is a resort is there. In that resort we made one green house, poly house. They are producing in their resort all organic crops, and they are serving their people with this organic crop, and organic vegetables, also selling their organic vegetable. And many people got job because of this development of this incorporation of this organic cultivation system. Healthy food they are getting, and in the hotel directly. Okay, so so this is another challenge we have taken. That is, you know, the bell pepper cultivation, one of the tedious cultivation system, because from the seedling to post harvest it has so many types of diseases. It infested by so many types of pathogens. So we have taken this challenge to cultivate bell pepper in a poly house. This is the, just see the color of the plants, just see the health of the plant, just see the, this is the harvesting time. They are harvesting bell peppers from this poly house, and they are getting good market value from these organic bell peppers. And also we have created jobs for many people for this system. So beside this, we have, because our metropolis increased vertically, so in case of metropolis, we have also introduced the organic cultivation system using a 4 feet by 4 feet tray, where we are making 24 square feet of, more or less 24 square feet of area in a small 4 feet by 4 feet basement, basal area, and where we are producing organic vegetable for 5 family, one tray for 5 family to get organic vegetable around the year. at least to sustain their family. Okay. So beside these also, these are the some model where we have introduced different types of crops in the organic cultivation system. Also we have introduced organic system in hydroponic model. Now this is a newly started venture. So we will utilize this organic cultivation system in a hydroponic system where we are trying to produce commercially important crops like lettuce, like many other asparagus, lettuce, and different types of lettuce we are trying to cultivate here in the hydroponic system. And just see the growth and health of this thing. So beside this, during this pandemic time, I have visited so many farmers group and I have given training to them. And every weekend I visit different places where I have tried to motivate my farmers friend that cultivation should be a cheaper one. I have converted the cultivation system per acre per day only 20 rupees, 3 bigha of land per day, only 20 rupees investment to get the crop. Only 20 rupees investment, or per bigha only 7 rupees investment. Okay, only 7 rupees investment per bigha of land per day for cultivating. Just don't take 1 cup of tea, that will help. Just don't take 1 cup of tea, that will help to cultivate your land organically. So it's not a costly effort, it's not a costly journey, but people are fooling us. If you go to the any super mall, they will sell all these products in 3 times 4 times costliest than that of your inorganic crops. But that way, actually, they are actually fooling us and getting money from that. So earning the money, just fooling us. But organic cultivation truly is the cheapest way of cultivation. This is another area. It's a canning area where the peoples have been trained for this particular purpose. This is Jhargram area in West Bengal. This is Jhalda in Purulia. Okay. So I have more or less reached to the end of my talk, and probably I have completed my talk in the stipulated time. So my dear friends, this is a concluding slide for you. As I have tried to do something to translate my knowledge to the societal level, and I know all of you having, those who are right now participated in this particular seminar, all of you having many new ideas. So please write some new story here. After few years or few months, I will be in a seminar. I will hear your talk, and I will be impressed with your talk, and I will jump from my seat and I will give a clap for you, and I will tell you, well done, my dear friends. So please, remember my message. It's an earnest request for all the participants. Please try to do something for the society, because society is looking for something from us. And if we can try means something for the society, ultimately we can make a big castle on that. So thank you very much. Thank you for your hearing. And if you are interested about my research papers and publication, please take a snapshot on that. I have already published more than 380 publications right now. You will get in the research gate. And Monalchari sir, also your blessing is there. This year I have been included 2% list of the Stanford University list too. Okay, sir. Thank you very much, sir, for providing me this opportunity. Thank you.
Thank you, Professor Acharya sir, for your very nice lecture, amazing lecture. I hope that everyone has enjoyed that. And now we'll take some questions. Those who are having questions, they can ask the questions. Please unmute yourself and ask your questions. Open for questions.
Hello.
Yes, sir.
Survase.
Yes, sir.
Let there be only 3 or 4 relevant
Okay, sir.
questions to
Okay, sir.
Dr.
Okay, sir.
Professor Dr. Krishnendra Acharya.
Okay,
Because
2 or
I had
3
to-
questions, please.
I have to sum up.
Yes, sir. Yes, sir.
Sir, hello. Sir, my question is that
You please
am I
tell your
audible?
name,
Go ahead.
please. Your
We
name,
can-
please.
Sir, I am LKV Power from Amravati.
Yes, Pawar sir, we can hear you. You go ahead.
Sir, being a PG student in botany, sir, how one can work in organic farming like Dr. Acharya sir? We need some guidance from Dr. Acharya sir to work in the field of organic farming, including this small capital, or how can we initiate our work in organic farming?
Hello, can you hear me? So, so it's a very simple technology. Number one. Number two, for a class 12 pass student, person can understand this thing. It's a easy way to translate our thoughts into the product one. So, if you have any interest on that, please talk to me. And also I have given all the methods what we have introduced in the field level. If you have any query on that, so I have no problem to answer on that. And it's a very simple technology, and if you are interested, you can come to my lab also. I will train you, no problem. Okay, Parvar sir.
Thank you, sir.
How are you, Parvar?
Sir, I am very fine.
Yes.
After seeing you after a long time.
Yes. I can remember you too.
Yes, sir.
Hello.
Yeah.
Yes, madam. You can go ahead. Narwade
Yes,
madam,
sir.
you can go ahead.
Yes, sir. I have a question, sir. Sir, do you need the government license for using such microbes in directly field?
Very important question. Very important question. When you produce anything for your own field or own consumption, there is nothing called license for that, because you are producing your own material for your own cropping system. So when you go for selling this thing, that product into the markets, that needs so many permission for that. Okay.
Okay. And okay, sir, how these farmers are maintaining the needed CFU per gram for the field?
No, that farmers, I have shown you that thing. All the farmers directly linked with my laboratory, number one. So I always give them the mother culture. Why that culture is needed? If you culture your thing, subculture your thing. Yeah, somebody is talking.
Please unmute yourself. Please don't disturb others. Hello. Please put off your microphone. That is disturbing. You are requested to put off your microphones. Please, it is disturbing.
Okay. Can you hear me? Can you hear me?
Yes, sir.
Yes, sir,
Yes.
we can hear
So
you.
okay. For that reason, I just make the cultures here. I always make the mother culture here, and I always support them with the mother culture. Number one. Number two, that culture, when you go for regular subculturing of any culture, after certain period of time, it will lose its viability. So we have to be that needs a specific scientist to understand the health and viability of the product. So that I am maintaining in my laboratory. I again resurrect that thing from soil to return back to the laboratory. Then I always take the best culture, which is a potential one. Then ultimately I always give them the best culture, number one. Number three, I always try to get culture from their field only. Okay. So when I work with any group, I always take collect the soil from their locality. From that locality, I always try to get the pure culture of this type of pure culture from their locality, and then I try to transfer this thing again into the field after a mass propagation. So they are not producing; they are just producing all these things in their culture media, and they just pour it in their spray machine and transfer this thing in the soil. Directly they are producing, they are putting in them in the spray machine and spray over the field. That's all.
Okay. And sir, one more question is that if suppose the farmers, some farmers might be the immunocompetent for the such microbes, then in that case, are you taking their head?
Hello.
Just
Hello, Acharya.
yeah.
Don't answer till he stop everything. You all unmute your mics first. You are disturbing the audience. Yes, sir. Go ahead, sir.
Okay, so in that cases, I always there is a techniques we always use when they use these microbes for production and all these things. They always wear mask and gloves for making the things all. Okay.
Okay, sir. Thank you, sir.
Okay, I think.
Yes, sir. We have covered most of the questions.
Yeah. Now, from Professor Dr. Krishnendu Acharya, I developed a technology from lab to land. It is a practical solution. See, so much of disturbance. What is that going on? I don't know.
Yes, all are requested. All participants are requested to.
Even when that professor was talking from Deccan University, Australia, there were people who were talking. It was not good.
Please move.
So it is a very practical type of thinking, because what farmers need in this country is this particular type of technology. Here is an young leader who has developed a cost-effective technology, which is the need of the hour. If you want to double the income of a farmer, there is no other way. Just go for such kind of technology, indigenous technology, and also use the organisms and in such a way that they will become the compost and also biofertilizer and so on and so forth. So nowadays, the organic farming has taken up, and Professor Dr. Krishnendu Acharya has explained all the procedures, technicalities, and also methodologies, and also fabricated for the benefit of the farming community. He is a farmer's friend. And one cannot forget a farmer, because without agriculture, there is no culture in any country. No country can progress without education and agriculture. I think Professor Dr. Krishnendu Acharya deserves all compliments and congratulations. He is a renowned scientist and also a farmer's friend. I congratulate you, Professor Dr. Krishnendu Acharya, for your dynamic talk and very good information you have given to the benefit for the benefiting the farming community and young leaders who are going to come and take up the sustainability of agriculture in the years to come. I thank the organizers, Dr. Mulani and others, and also Dr. Deshmukh sir, for having given me an opportunity to be the chairman of this particular session. Thank you very much.
Thank you.
Okay,
Hello.
sir.
Hello, sir. One more question I have.
Now you can mail him.
Okay, sir. Fine, sir.
Okay, you can ask later on. Okay, thank you.
Thank you.
Thank you, Acharya sir. Now we are moving towards technical session 2. And the chairman of this technical session is Dr. Ashok Chauhan, sir.
Purvanche sir. Hello.
Yes, sir. Yes, sir.
You unmute all the people. Make speaker as a co-host.
Yes, yes, sir.
Start because and ask one person to take the questions.
I know. Sandeep, सगळ्यांना unmute करा. Unmute करा सगळ्यांना unmute करा. तो problem नाही.
And hello.
Yes, sir. Yes, sir. Doing it.
Ask one person to take questions. Not all the persons should ask the questions.
Okay, sir. Okay, sir.
Dr. Mulani, I'm already corrected.
Yes, sir.
I'm already corrected.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Yes, yes. Surosis, sir. Hello.
Hi, yes, sir.
Yes. So we are having a second session, and Professor Dr. Ashok Chauhan is the chairman, and Dr. M. Sudhakara Reddy is the speaker for that this session. I request my colleague Professor Dr. Survase to introduce the chairman of this session.
Okay, thank you, Mulani sir. It's my pleasure to introduce to the chairman of this session, Dr. Ashok Chauhan sir from Department of Botany, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. If you see his biodata, it's a very huge biodata. I could not summarize it. It's very hard to summarize it, but I will just highlight some of the points out of it. So far, he has 30 years of teaching, research, and administrative experience. As far as his administrative experience is concerned, he was a vice principal and principal of Vasantrao Naik College, Aurangabad. He was also officiating registrar, director BCUD, and controller of examinations, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. He also worked as a controller of examinations, Savitribai Phule University, Pune. As far as his academic experience is concerned, so far he has published more than 125 papers in journals of national and international repute. Also, he has 9 books to his credit. He has also 1 patent to his credit. He has also completed several research projects funded by UGC and other funding agencies, Government of India. He has also guided more than 25 students so far. So far, he has visited several countries, including Taiwan, Singapore, Philippines, and Netherlands. As far as awards are concerned, he is the Fellow of Indian Botanical Society. He is also Fellow of Indian Phytopathological Society. Apart from this one, he is the founder, General Secretary of Marathwada Botanical Society. He has also worked as a member of peer team of NAC Bangalore. With this brief resume, I just hand over this mic to Professor Ashok Chauhan sir. Professor Ashok Chauhan, please carry on.
Thank you so much, sir. Friends, I'm very much thankful to the organizer of this conference, Advances in Fungal Biotechnology, organized by School of Life Science, SRTMU University, Nanded. We are very much delighted with the first lecture by Dr. Acharya, which was chaired by our eminent scientist from the field of plant pathology, Professor Dr. C. Manorachari. Now we are with the second lecture. Friends, for the second lecture, we have an eminent speaker, Dr. Professor M. Sudhakar Reddy. He's a well-known professor and head of the Department of Biotechnology of Thapar Institute of Engineering and Technology. His work is related mainly with the biotechnological field and metabolic activity, particularly he looking after that one.
Yes. Sandeep.
For today's lecture, because we are already for today.
Sir Chauhan sir, you are not audible. Hello. Okay.
Yeah.
Okay, okay, sir. Slides are visible now.
Dr. M. Sudhakar Reddy will go to speak on ectomycorrhizal fungi. Without taking much time between the audience, learned audience, experts, and the host, I will request and I will hand over and I will request to the organizer to please share the screen of Professor M. Sudhakar Reddy, and he will continue his lecture.
Yes.
Organizers, please.
Screen is already shared, sir. Reddy, sir.
Yeah. Okay, sir. Respected Professor Chauhan, thank you very much for your introduction. I am very much delighted and also thankful to the organizers for inviting me to share some of our experiences, what we are working at on fungal systems. And I'm also thankful to Dr. Desmukh. So he was insisting me since many days to give a lecture, but due to some busy schedules, I really could not. But anyway, it's a good platform, at least for me to share some of the experiences in these particular cases. Though we work on different systems for this particular talk, I just chosen that what are the role of glutathione. Okay, so especially in metal homeostasis in different fungal systems. Of course, we use a model of ectomycorrhizal fungi, so the work is continuously on the mycorrhizal system. Okay, so as everybody knows, the mycorrhiza. So mycorrhiza is a symbiotic association between the plant and fungi. And so everybody knows about that. There are two types of, at least major types of mycorrhiza. One is an ectomycorrhiza, which basically forms an association with the trees, and also the arbuscular mycorrhiza, which is with every plant which is going to be have an association with them. This mycorrhizal form fungi especially forms symbiotic association with plant roots. And by having this association, it also improves the nutrient uptake and also the water uptake. And as a whole, totally, it also improves the growth of the plant. If it's an agricultural crop, so they also improve the yield of them. And it also protects the plants from various biotic and abiotic stresses. And when you come up with the ectomycorrhizal fungi, because it is ecto, because it says that it doesn't penetrate into the tissue, so it only occupies the intercellular spaces of the cell. So that's why, and forms as a sort of a sheath around that, so it looks like a net. So that's why we call them as a hunting net, which is also associated with them. And of course, you see that this is the ectomycorrhizal slide where you have a extra radical mycelium which travels along in the soil and uptake various nutrients and other things and transport to the plant system. And in the case of arbuscular mycorrhizal fungi, it also forms a sort of structures called arbuscles and also vesicles in the soil. So that's how these mycorrhizal fungi have a sort of an association with these plant systems. So for our further lectures, so we have chosen two different types of mycorrhizal fungi, especially ectomycorrhizal fungi. One is a Lacaria bicolor and the other one is Hebuloma cylindrosporum. The idea of selecting these two fungi is because both their genomes are available now, and the first ectomycorrhizal fungal genome, which was sequenced, is Lacaria bicolor, later followed by Hebuloma cylindrosporum. And of course, we are also working on the other genome projects, especially we have sequenced already the one of the tropical ectomycorrhizal fungi, that is Physolithus, so in our laboratory, and we are going to come up with all the the annotated genes very soon from our lab. Okay, so these are the two fungi. From here onwards, I'm going to talk about these two fungi and how do they behave in response to the different types of metal stresses and all. So when you come in to see the metals or heavy metals, which are basically toxic, and of course they are natural components in the earth crust, and we cannot degrade or you cannot destroy them. Okay, so we call heavy metals whenever their density or specific density is above 5 grams per centimeter cube. And these heavy metals can be of essential, like zinc. Okay, so some of the times cobalt, and some of them are toxic, like your cadmium, lead, mercury. So both essential and non-essential. And all these heavy metals, they enter inside the cell and alter the cellular functions. It inhibits the enzyme activities, or it also do a lot of other so affect the effects to block the different biological processes in the system. And of course, due to the toxicity, it also causes various types of diseases. So now, how these toxicity effects can be protected by the different types of mycorrhizal systems, especially in fungal systems, also on ectomycorrhizal system. So one is that you can avoid, so which is basically called as avoidance. Avoidance in the sense that it will these systems will not allow the metals to enter inside the cell. Okay, so that's why, so it precipitates a lot of extracellular precipitations, like they release different types of organic acids and also which basically chelate these metals. And also it will be absorbed on the cell wall, and so you can have a bioabsorption to the cell, or whatever the things which have been entered into that, so they will be thrown out by the process called as efflux. So these are all the different mechanisms which you could see avoidance. The other one is a tolerance, in the sense that many of the organisms have the ability, even though if they enter inside the cell, okay, so these will be sequestered and they will be thrown into the vacuole and make them non-available and also make them non-toxic form. And some of these compounds which are produced or sequestered or secreted by these organisms include metallocyanins. So metallocyanins are very small cysteine rich peptides, with the peptide size is just 34 amino acids, and of which 20 to 25% of the amino acids are cysteine. Or you can have a glutathione. So glutathione is also induced, and it also sequesters the different toxic elements. And of course, this is most important component which is induced in response to any sort of stress which is created to the organism. And the other one is that most of the plant systems, including some of the eukaryotic systems like fungi, also they produce phytokeratin. Phyto itself means plant, and keratin means that it will chelate these metals. If you look into this diagram where the different mechanisms have been so displayed, one is that like extracellular precipitation. Okay, so where like organic acids will react and chelate these metals, or they can be binding onto the surface, which is called as a binding. And then other one is enhanced efflux, which we have already discussed. And then if at all they enter, so they can be sequestered or chelated by internally, which is called as some of the cysteine rich peptides, metallocyanins, or it could be enhanced due to the induction of glutathione or production of glutathione. Or you can have a subcellular compartmentation, like throwing them into the vacuole, or you can have a compartmentation of the glutathione metal in the form of a vacuole. So these are some of the mechanisms which every organisms, especially the fungal systems, can do to avoid or to tolerate against the toxicity effects which are produced by these organisms. I worked a lot of things on metallocyanins and different fungal systems and all, and you see that this is a protein, because you cannot call it as a protein because it's just 34 amino acids. So, but it's a small peptide, and you see the number of amino acids, and also you have a similar pattern, which you could see like C, X will be any amino acid. So you have a C terminal, and you have N terminal and C terminal, and most of these metallocyanins from different fungi, starting from so Bacillus, or you have a Suillus, you have a so then the Agaricus, Bisporus, Lacaria, Suillus, or Pisolithus. Anything you see that this is the peptides which have already cloned, sequenced, and tested their efficacy. And also, in fact, you see that this is the pattern CXC motifs which are present on its C terminal end. And of course, some of the metallocyanins can also be a bigger one, maybe around 120 to 200 amino acids, but where you will have the same pattern at your N terminal end also. And this is just to give an explanation that most of these metallocyanins are induced so to cater the toxicity which are induced by the copper. And you see them that this is a yeast, which means that you can clone this gene and you can transform them into yeast. And these are all different types of yeast mutants, which like for a yeast sensitive, copper sensitive or cadmium sensitive or zinc sensitive yeast mutants can be developed by deleting the resistance gene of that particular metal in the system, and then you can complement these genes, and you can see that if you transform, so these are the genes, the transformed cells with metal without, with genes or without genes. And if you see them here, suppose if you grow them in a normal medium without any metal, so every cell, though it is empty vector transferred or normal wild cells, or so the each cells transformed with metals. Like this is here, it's called as a Suillus himalayensis, one of the basidomycetes fungi where we have cloned and expressed it in a yeast system. You see that whenever this is a wild type, and so it is able to grow at 150 micromolar of copper sulfate. But if it's a sensitive mutant and do not have the tolerant genes, and if you just transfer an empty vector without any complementation of the gene, so you see there will not be any growth, which you could see anywhere. And whenever you transform them with the metallothionein, these genes, you see that they were able to grow luxuriantly in this case, which we normally call them as a drop assay or a functional complementation assay, which can clearly shows that the function of this gene is to protect the organism from the toxicity. Whenever you have this gene here, okay, you will see there is a growth. If you don't have them here, so that it will die. So this is the experiments which have been done in our lab previously, and we have done upload many genes related to that. But one of the important thing which I would like to mention in this particular slide is that most of these metallothioneins are either reduced by copper or maybe zinc, but not by the other toxic elements like cadmium and other things which are there. So then we wanted to know that how does the cadmium or arsenic or any other metal can be sequestered, or they will be protected from this toxicity, where we have done or we have concentrated on the glutathione metabolism. So glutathione, everybody knows that it's most abundant antioxidant which is present in every organism, including humans. And the basic function of this is that it will basically neutralize the free radicals and also the reactive oxygen species, which are generated during the stress of both abiotic and biotic stress. And also it have like more affinity because it contains this SH group because of the cysteine, glutamine cysteine, and so that's why you have SS group. So SS group basically bind with the different metals and also some of the genobiotics and make them into non-toxic, which are there. And also the binding metals and genobiotics and also compartmentalizing them into the vacuoles. So that's the reason why this glutathione could play a very important role in protecting the organisms from the toxicity of the metal. If you see that you cannot call, it's not a glutathione is not a gene derived product, it's a metabolic product. Okay, because it's not a single gene which like metallothionein. So like metallothionein is a single gene. Okay, so that directly gives you the peptide, but glutathione is not. So glutathione is a tripeptide because it only consists of three amino acids like the glutamine, cysteine, and then so you can make them into number of times. Okay, so that will be called as a glutathione, which you could say them. So glutamine, cysteine, and glycine. Okay, taken n number of times is called as glutathione. And then it's a because the glutathione synthesis, if you see in the system, how do glutathione is synthesized? Okay, so there are two enzymes which are involved. One of the enzymes, like if you have a cysteine and glutamic acid, okay, so they will combine together by and form as a dipeptide by an enzyme called as gamma glutamyl cysteine synthetase. Okay, which is an ATP-dependent enzyme, and this gamma glutamyl cysteine synthetase, after synthesizing the dipeptide glutamine cysteine, okay, so will be so glutathione synthase will help in synthesizing by adding the glycine to it and taken a number of times. So which clearly indicates that you have two genes. Of course, glutathione will further give you by taken n number of times glutathione is a phytoculatin. So that the enzyme other one which is responsible for phytoculatin synthesis is a phytoculatin synthase. And so you see that here glutathione is basically synthesized by two enzymes, gamma glutamyl cysteine synthetase and glutathione synthase. So now in our thing, we would like to understand the molecular mechanisms behind these things. So we started working on this and have cloned and amplified these genes and other things which are there. And you see that you have two types of things, like divalent glutathione and trivalent glutathione, which will be compartmentalized into the vacuole. So the overview of the my present study will go like this. So we have taken the ectomycorrhizal fungi, we have cloned the genes, and we have estimated the glutathione content, and we have seen that how do they play an important role in the tolerance of. Okay, this is just to give that. So before we do anything, so we have to see that the organisms what we are trying to test, they are really sensitive or tolerant to these concentrations. So we used, I have already mentioned that we have used like a Lacaria bicolor and Ebuluma cylindrosporum. And if you see that when you supplement with the different concentrations of the cadmium or arsenic, you see that there is a decrease in the growth, which means that these metals are highly toxic towards the one, but it is able to grow and take up high concentrations of the metal. Then once then we have to see that how much of this metal has been accumulated inside the mycelium. So we do, okay, so you can treat the mycelium with the metals, and we digested with, okay, so perchloric acid and nitric acid. Then we have performed atomic absorption spectroscopy to see that the level of accumulation, which clearly shows that as you see that with the increase in concentration, okay, so there is a increase in the accumulation of the metal or uptake of the metal, but at higher concentrations there is a decline in this, which clearly indicates that the growth also got affected. So that's why you have a lesser growth. So accordingly, you will have a lesser amount of okay, so metal which you can expect both this organism. So this is in correspondence to the cadmium, and this is in relation to the arsenic. Okay, so then we also estimated the glutathione content. You see that both Lacaria bicolor and in response to the metal stress, like this is a metalloid, arsenic is a metalloid, and the cadmium is a metal. And you see that as you increase the concentration of the metal in the medium, and if you see that there is an increase in the glutathione, it means that glutathione is directly involved or induced in response to the metals or metalloids which we have seen, and same thing happens with the arsenic also. Then after that, we also wanted to test, as we already discussed, that there are two enzymes, the gamma-glutamyl cysteine synthetase and glutathione synthase. These are the two enzymes which are involved in the synthesis of glutathione. So we wanted to know that when you increase these concentrations of the metal in the medium, and then we try to estimate, okay, so how much amount of enzyme of each of them is present, okay, at a particular time. And so we have estimated this, and you see that as you increase the concentration of the metal, like a cadmium or a metalloid like arsenic, you could see that there is increase in both the enzymes in response to this toxic component, both in case of Lacaria bicolor and the Hebuloma cylindrosporum, which you could see. Okay, so then after having this preliminary information, then we would like to see that whether we can clone these genes and then characterize it and see that if you can put them into any expression vector to see the functional assay. And so this is the RNA which we have isolated. You see that if you get an RNA of such kind, so it's a good quality RNA. And if you don't get sharp bands of at least these two, it means that your RNA might have been degraded, and these bands corresponds to your large and smaller okay, ribosomal okay, units of that. And then once you do that, and then we made a cDNA synthesis by using because being a eukaryote, so you can use oligo-DT and you can synthesize the cDNA, and so you made a cDNA. And just to check that the cDNAs are made, you can use some of the genes which are the housekeeping genes like actin or tubulin, and then you could see that there will be an amplification with cDNA, which indicates that you have converted your RNA into a cDNA. After that, we have used the genes or these gene-specific primers for okay, gamma-glutamyl cysteine synthase and also the glutathione synthase. And you see that there is an amplification of these genes too, which we have done it. After that, we have cloned and sequenced. And also we did a relative expression by using a qPCR or the real-time PCR. Where you treated, you take microbial fungi and give a stress of either cadmium or copper for about 48 hours, and then you isolate the RNA and convert them into cDNA, and then you see that by using a qPCR, can you see whether due to the induction of these are due to the metal present in that, whether these get induced or not. And you see that there is a this particular slide can give you about the gene and expression or gene induction. You see how much as you increase the concentration, okay, there is a fold increase of this compared to the control, and you see that almost like a 20-fold or 30-fold increase of these genes, okay, in response to the stress which have been provided. And these slides, these figure shows related to the cadmium, and these are related to arsenic in response to the Hebuloma and also the Lacaria bicolor, which are there into that. And so this relative expression of both these genes have increased in response to both cadmium and okay, arsenic. which can throw a light on the fact that both glutathione biosynthesis pathways actively induced both in these systems when you expose to the cadmium and arsenic. Okay, so this observation can also support us the fact that whenever the mycelium is stressed with metal or metallites, okay, so you can have a active glutathione gets immediately depleted, which indicates that glutathione pathway is induced in this particular. After cloning the genes, and then what we did is that we have cloned them, and then we have transformed them into okay, so the plasmid, especially the plasmid is the shuttle vector, means that you can put them into E. coli or you can put them into yeast, both prokaryotic and eukaryotic systems. You can transfer this plasmid. That's why it's called as a shuttle vector. And then after transforming these two genes into the vector, and then we have transformed first into the bacteria just to get a sequencing. After that, we transform them into the yeast system. And after that, we have cloned and sequenced, and this is after the sequences got deposited in the NCBI database. And these the 4 genes, 2 from the Lacaria and 2 from the okay, so Hebeloma, and these are their accession numbers, which are already available in the databases. And this is the size of a gene, which is about 1.85 kb. Okay, this is like 1593 base pairs and so on. And you see that this protein is around 617 amino acid, and whereas in the same protein in the case of Hebeloma it is 679. And so like that, so there may be variations from one organism to other organisms irrespective of the protein will be the same, but they will be having variation in sizes. And these are their theoretical okay, isoelectric point and their molecular mass. So this is how we have characterized all the genes. And then you do the blast analysis to confirm that you have cloned a right gene, and you see that both these genes have shown okay similarity with the glutamate cysteine synthetase, which clearly indicates that you have a right genes to be cloned. And these are all how we have done it. And then we compared these proteins to with other fungi, not only on mycorrhiza, but in general, different fungi. And so you have a pattern which you could see that these are basically conserved regions within these okay genes. This is a glutathione synthase gene. Okay, basically it is ATP binding domains, where you could see these blue highlighted colors are ATP binding domains. So which are common across the different fungal systems, not only on mycorrhiza. You could also see Lentinula or Armillaria or any other fungus which you see, including the mycorrhizal fungi, though there may be little variation from one amino acid to another amino acid, but they have highly conserved in their pattern. So then we also analyzed for the phylogenetic analysis to with different other okay groups of fungi, which includes your Basidomyces, Saccharomyces, and also Ascomyces. And these genes were exactly okay, formed together with the Lacaria and also Hebeloma with the Basidomycetes group, which is there in that particular cases. So this is a gamma glutamyl cysteine synthetase, and also this is a glutathione synthase. You see that okay among the Micromycetes, okay, so Actomycetes or Basidomycetes, they clump to that, which clearly indicates that we have cloned the right genes, and also the evolutionary how they were related could be seen by these phylogenetic analysis which are there into that. Okay, so after that, what we did is that whether they really protect the organism or not, you need to know after cloning everything. So we have done the heterologous expression by transforming them into gamma glutamyl cysteine synthase and glutathione synthase genes into the yeast mutant. And we have used the 2 different types of yeast mutants, which are basically lack of the GHS1 is basically lacking of the first enzyme, and GHS2 is lacking of the second enzyme. It means that when you grow them in presence of metals, this glutathione cannot be synthesized because in the first mutant, you don't have this gene. It means that there will not be any dipeptide is formed. So because of that, there could not be any synthesis of glutathione. And in the second case, even though there is a first enzyme is present, but this dipeptide will not be converted into glutathione because this enzyme has been deleted from these yeast mutants. So it means that whenever you complement, so this is what these mutants are. So it means that they really cannot grow in presence of any of the metal, especially cadmium or arsenic. Suppose if you complement, as we have already cloned this gene, which in the PFL61 shuttle vector, and if you complement and if you transform these genes into these mutants, then if you grow them in presence of metal, if they really grow, it means that this gene is functioning and allowing the organism to grow. If they don't grow here, it means that this is the gene which is not responsible for that particular purpose, for which we use two types of test. One is called as a drop test. The other one is called as a liquid assay test. Drop test is this is called as a drop test. Again, you see this is a okay. So wild type yeast. Okay, wild type yeast will have a glutathione synthesizing ability. So if you grow them in presence or in absence of the cadmium, you see there is a normal growth. But if you see you take the yeast first gene mutant, and instead of complementing with the gene, you just only put an empty vector without any gene of interest, and you are growing them in presence of cadmium, and because there is no gene which can protect this, so you see that there will not be any growth. As soon as you transform them with a glutathione gene like Lacaria bicolor gamma synthesis or other one, you see that the organism is able to sustain. So this is in relation to your Lacaria bicolor, and you could see them that there is a clear-cut indication that these genes really helping the organism to synthesize glutathione and also able to protect. Okay, you see that 40 micromolar of cadmium, which is highly toxic to the yeast. Okay, so but it's still able to grow them in this particular case. And in this case, if you see, we are using sodium hydrogen arsenate, where 100 micromolar also the organism is able to grow. So this is how in relation to the Abyloma, same story. And so they were able to protect. It means that you can rescue from the sensitivity of the metals by complementing these genes into the yeast by transforming and looking into these particular cases. These are all basically called as what called as a drop assays. And then we also tested on the liquid assay. So same cells have been grown in the liquid medium and exposed to various concentrations of cadmium and copper. And if you see that this is without empty vector, so there is absolutely as soon as what we do is that we grow them 2 days. After that, we put a metal, so there is a sharp decline and the cells died. The genes which were complemented with these glutathione synthesizing genes, so they were able to protect these organisms both from the cadmium and also from the arsenic in both these particular cases. So this is how the complementation assay can will help us in protecting that, and same thing in relation to the so arsenic and cadmium, which you could see there. So after having all these studies, which have clearly shown that the glutathione, which is induced in response to the different metals, so they were able to protect the organism. So we also did some sort of a proteomic analysis in the sense to see that what are all the different types of genes which are induced in response to the metals. So we have done proteome analysis because you see that what we have done is that we have exposed to the mycelium to the like cadmium, like 40 micromolar cadmium. After that, we have isolated. So then we have grown it for a while, and then we have isolated the total protein from this mycelium. Then we did a phase analysis, LDSS phase analysis. And then we have subjected for the LC-MS, like RP, reverse phase liquid chromatography, ESI, and also QTOF MS analysis. And then we have used with and without metal treated mycelium, and we have done the comparative analysis to see that what are all the different genes which are differentially expressed in relation to the metal stress which have been given. It's not only glutathione, it will also give you complete profile of the genes which are induced in response to the metal. This is a proteome analysis, and which we have started from our lab, and you see that. So this is how you could do this RPLC ESI QTAF analysis. Like you take the mycelium and you give a treatment with a metal, isolate the total protein, subject it to the SDS phase, then you digest it with like a trypsin, and then you can subject it to for the electrolysis ionizer. Okay, then you study, or you can also do the fragmentation and subject it for the MSMS to see that what are all the different types of the compounds or the metabolites which are induced in response to the stress which has been given by this one. And this is the case. Okay, so after that we have okay, so compiled that what are all the different metabolisms or the activities which are affected in response to the metal stress which has been given. And in every metabolism, starting from you see that how the metabolisms are also how the genetic information processing systems like transcription, translation, replication, and also the other things get affected. And what are all the different environmental information like how this membrane transportation and signal transduction pathways get affected at a cellular level, how the transportation processing can affect at enzymatic level, how these things can be okay, affected. So this is a total idea. I'm not going into the details of each and everything. And so that all these like carbohydrate metabolism, amino acid metabolism, energy metabolism, or DNA, nucleic acid metabolism, both DNA, RNA, lipid, secondary metabolites are glycan, okay, so biosynthesis or genobiotic degradation metabolisms. They're all affected, and also many of the genes which are induced, and some of the genes are upregulated, some of the proteins are upregulated, or some of the proteins have been downregulated, which you could see at a genetic level. The transcription got affected, translation got affected, replication got affected, then ribosome biogenesis or synthesis of ribosomes got affected, then folding of the proteins, okay, then okay, then sorting of the degradation of the proteins, or some of the proteins like histone-like proteins which are associated with the chromosomes, they all got affected by this metal stress. Then membrane protein system or membrane transportation system was severely affected, and signal transfer. Once you get a membrane transportation system get affected automatically, okay, it also gets affected with the signal transduction. Then like you have a transportation and metabolism, cell growth and death. So all these things got affected as a whole. This is the total protein profile, okay, where and all these genes got affected can be seen in this particular case. And so they which could be look into that the level of means that if you see that these colors are like ABC, so that that contribution of each of these, but whatever the number of genes which are like differentially expressed proteins, so these are all the genes like metabolism of terpenoids or polyketides or glutathione metabolism or energy metabolism or nucleotide metabolism, amino acid metabolism, catalytic metabolism. So what are the genes which gets affected more severely? Like that B is a genetic information processing, C is like your environmental information, and D is a cellular process, and the E is a response to the oxidative stress. You know that metals basically provide an oxidative stress. You see that there are many genes are getting affected, or reactive oxygen species, or many other processes get induced in response to this particular process. So this is how you can document, or you can make a complete profile of proteins which get affected in this particular process. And now I'm just going to give you my last slide in this particular case, which clearly indicates I'm not going to go into the other genes, but see these are all the different proteins got affected because of the metal stress in relation to glutathione, and this is the protein ID, and so you have a like a monothiol glutathione or glutathione reductase or ascorbate peroxidase or glutathione S transferase or synthetase, which are all involved in the glutathione metabolism. And so these are all the threshold values. So after beyond some threshold value, we assume that there is a change in the pattern, and so below that there will be down regulation of these things. So the upregulation of proteins involved in glutathione metabolism, which can justify that glutathione will play an important role in inducing cadmium tolerance in the Laccaria bicolor of the fungi, which we have done it. And it also have a dual protection mechanisms. It acts as a metal scavenger during metal homeostasis, and it can also act as an antioxidant during the synthesis of these particular cases. Okay, so this is all about the different things which you have done, which clearly indicates, and you see this is the mechanism. Again, I said glutamate and cysteine. Okay, so you have a first enzyme, glutamate, so how the glutathione synthesized, which has been got. Okay, so they will bind with the metal and then will be transported into the vacuoles. And so this is one of the activities, scavenging activity, and this is the another activity that how it affects the stress, especially creating ROS, and then you see that how it can also prevent it from the stress condition. So which clearly indicates that glutathione will play an important role in this particular process. So both, just to conclude my talk, both the ectomycorrhizal fungi like bicolor and Immobilization, they are tolerant to both the metals which we have tested in this particular study. And glutathione metabolism is the key mechanism which is involved in cadmium and arsenic, mitigating the ectomycorrhizal fungi and genes actively induced under stress. As I already said, copper and zinc are basically taken care by the metallocyanins, again produced by the same organisms. You have the proteomic analysis of the this particular Lacarea bicolor in response to cadmium. I have provided the deep insight into the cadmium toxicity mechanisms and their responses to the ectomycorrhizal fungi in its mitigation. And so it also alters various metabolisms, which we have already seen, like starting from carbohydrate to any other metabolism. So in defense, these fungi induce signaling pathways, activate various proteins which are involved in mitigating the oxidative stress and also glutathione metabolism. So these are all the things which we have done with these particular things. And thank you very much for your patient listening. And I'm ready to take up any question if you have. Once again, I thank the organizers for giving me the opportunity, and also my chair, Dr. Ashok Chauhan, and also to Dr. Sunil Desmukh, and of course, eminent mycologists who are present in this conferencing, including Professor Manohar Acharya, Dr. Atri, and many of my colleagues like Acharya and many others, where I have not seen them in their names, to one and everyone, including Dr. Shashireka. Thank you very much for your patient listening. Thank you very much, sir.
Thank you, Professor MS. Now, hardly one or two questions, if anyone. If anyone questions, Professor MS, you are really given a very nice and informative thing regarding the glutathione metabolism, especially related with the two different mushrooms, that is Lacarea bicolor and Habeloma, right?
Yeah, Habeloma cylindrosporum.
Right. These two, these two different fungi you are taking for this study of this glutathione metabolism. Your work is really very much informative one, and I hope if there is no any question, then I must thank you for giving your valuable time and sharing your information to the audience, especially into this national conference organized by this SRTM University Life Science Department. Thank you so much, Professor Mulani, sir, for giving me the opportunity to work as an chairman for this session. And I really enlightened with hearing the views and thoughts of Professor MS Sudhakar Reddy. Thank you so much, one and all. And over to the organizers.
Okay, thank you, sir. Thank you, sir. This is the end of this session. And okay, this is the end of this session, and we will break for the lunch. Please enjoy the lunch at home only because of COVID. And
okay, I have my own tiffin. Don't worry, sir.
Thank you, sir. And
I brought my tiffin. Don't worry, sir.
Everyone has to do it now. There is no other.
Thank you, Professor Sunil. Thank you, Professor Mulani. Thank you so much.
And we'll.
And I wish all the best for your conference.
Thank you, sir. Thank you. Thanks a lot.
Yeah.
And we'll rejoin at 2:30 exactly. Okay, so we'll rejoin at 2:30 p.m. Okay, thank you, sir.
Is it the same link? Will it be the same link?
Yes, madam.
Okay, yeah, sure.
Same
Thank you.
link. Everybody
Same
will
link.
join for the paper presentation.
And that is
Oral.
paper presentation.
Oral paper presentation. Thank you so much.
Thank you. Congratulations, Ma'am Mulani.
Thank you, madam.
Bye.
Yes, thank you.
Hmm. What happened?
जॉईन झाली का बाळा तू?
हॅलो सर, आवाज येणार होता ना? सर्वांना वेलकम करा परत एकदा.
Hello, Deshmukh sir, did you join? Have you joined? Deshmukh sir.
ज्वारीची भाकर आहे आपल्या मुगाची डाळ. हे बांधण्यापेक्षा काय करा, कापूस झाला का नाही, ते सीलच केले. मोठी सेल त्यामध्ये वरून कवर आहे.
Hello, Deshmukh sir, have you joined? Deshmukh sir?
असं होऊ शकते.
झालेलं नाही. Okay, good afternoon, everyone. Now we are starting again, and thank you very much for joining again for this 2 days online conference on advances in fungal biotechnology. Myself, Dr. B.S. Rose, School of Life Sciences. Now we are moving towards poster presentation. Sorry, paper presentation, and for every participant, there are almost 21 participants who will be presenting their papers, and for every presenter 5 minutes will be given for presentation plus 2 minutes for discussion. And at the end of presentation, after 5 minutes, you can ask question also. And this question, for this asking these questions, you can use your chat box, either your chat box, or you can directly ask the questions. During this presentation, you will be on the mute mode. Kindly be on mute mode only, so that it is not disturbing the presentations. And everyone, I will like to request everyone to participate actively. And the sequence of presentation, I will announce the names one by one. Then out of these 21 presenters, best 3 presentations will be selected for the merit certificate. And so kindly note that your presentation is going to be judged by the judges. There are judges. We will not announce the names of the judges. They are there online right now. They are going to evaluate your presentation. So so first, I will just announce the names of first 5 presenters. Bhaskar Chaurasia from Bilaspur Central University, Guru Ghasidas Central University, Bilaspur, 1. Second one is Pathak Anupama from our school only. Third one is Deshmukh Shajia Sultana Khurshid Ahmad, Department of Zoology, Sri Shivaji College, Parbani. Fourth one is Dr. Umesh Pandurang Mogle, Department of Botany, JES College, Jalna. And fifth one is Dr. Sachin Agarwal. It's Santagadge Baba Amravati University. So these 5 names are there. We'll take this presentation one by one. And once we finish up these 5 presentations, we'll be again announcing next 5 names. So without much delay, we'll turn over to the presentation part. So I request first presenter, that is Dr. Bhaskar Chaurasia, Department of Rural Technology and Social Development, Guru Ghasidas Central University, Bilaspur. So Dr. Bhaskar Chaurasia, please share your screen. Dr. Bhaskar Chaurasia, are you there? Are you present, sir? Okay, it seems he has not joined so far. Second presentation will be by Pathak Anupama Prabhakar from our school only. Madam, are you there?
Call kara. Baharun call kara.
Okay, seems she has also not joined. Third one is Deshmukh Shajia, Sri Shivaji College, Parbani. देशमुख साजिया शिवाजी कॉलेज परभणी. नाही ठीक आहे. पार्टिसिपंट भरपूर आहेत, 64 आहेत. नाही ते कळणारच नाही ना, सगळं अनाउन्स करू. So next one is Dr. Sachin Agarwal. Dr. Sachin Agarwal, are you there? Call करा लागतो. नाही सोडून दे, कशाला कॉल, त्यांना कळायला पाहिजे. They should be online. We have declared at 2:30 we will. So we have instruction दिले already दिले. Dr. Sachin Agarwal. Okay, next one is Dr. Shraddha Ulle, Mahatma Phule College, Warat, Sant Gadge Baba Amravati University. Next one is Gaikwad Ujwala, MB College, Latur. No response.
Yes, sir.
Who is speaking? May I know?
Yes, sir. Myself, Ujjwala Gaikwad.
Okay, madam. You will be given 5 minutes for presentation. You can go ahead, and at the end of 5 minutes, there will be 2-minute discussion. You will be asked questions.
Sir, I'm facing problem in sharing screen.
Okay. I will permit you to share, sir. Multiple screen. Command. Hello, Ujjwala madam, can you share the screen now? Waiting.
I'm unable to scratch.
Just
Sir,
wait.
what problem is going? Actually, I'm not getting, sir. Please, sir.
व्हिडिओ पिन करा तुमचा, कदाचित त्याच्यामुळे होत नाही. व्हिडिओ पिन करा त्या मॅडमच्या पाहिजे. कुठे हे गायकवाड त्यांचं पिन करा. पिन वेटिंग रूम म्हणायला लागले, ती वेटिंग मध्ये जाईल.
Hello, sir.
Just wait, madam. No, त्यांना स्क्रीन करायचं झालं. Okay, madam, can you share now? Okay, Ujjwala madam, can you share the screen now?
No, sir. No, sir. I'm not getting PPT only on.
We can see you on the screen.
Yes, but I'm unable to scratch my screen only.
Okay, I have permitted multiple participants can share this screen simultaneously. It should come. Screen in PPT in again.
Can you make her the host? If you can make her there.
Okay.
There is one. Host naka karo.
लॅपटॉप करतात का? मोबाईल अजून शेअर केलं. शेअर करा.
शेअर नाही करा.
त्यांनी शेअर नाही केलं. त्यांची कुठे दिसली पण ती शेअर नाही केली.
Madam, I think you did not share the screen.
So, Gaikwad madam, are you presenting from mobile or laptop?
I'm presenting from mobile.
So
Hello.
At the bottom there is a markup screen share. No, there is a.
Yeah, there is one button of share.
Yes, you can share your mobile directly.
You'll have to select the presentation and then share. Yeah.
Pin केलाय व्हिडिओ.
Okay, Gaikwad madam, keep trying. So shall we call next one, sir?
Yeah. Okay.
Dr. Deepak Bhimrao Sate.
दीपक त्याचे स्टुडंट त्याचे स्टुडंटच आहे ते स्टुडंट.
Yeah. Who is going to present? Dr. Deepak Bhimrao Bhagwanrao Sate.
ते साठे सरांचे आहे. साठे सरांची स्टुडंट ती प्रेझेंट करते ती आता बोलते. पुढचं घ्या.
Okay, Mr. Gaikwad Manoj Ashokrao. Mr. Gaikwad Manoj Ashokrao, are you online?
अरे अरुण त्या लोकांना फोन करा ना मग ना. उमेश टाकलं का?
Gaikwad Manoj Ashokrao, are you online? Yeah.
मी ते एस लिहिले त्याला तरी करतो. Yes.
So, dear participants, we are in oral presentation session. Yeah. Gaikwad Ujwala, now we are getting your screen.
Yes, sir.
You know,
How
you share your file. So your screen is now visible.
Share the PPT. Yes.
Yeah, Gaikwad madam, just you have shared your screen. You keep on trying.
my screen? Sir, without PPT, can I give presentation?
Without PPT, how it is possible?
Okay, madam, you go ahead.
Yeah. Okay, you go on speaking.
Yes,
just 5 minutes. You speak on your topic, whatever that you are going to present here.
Yeah, sir. Good afternoon to everyone. Myself Ujwala Anantrao Gaikwad. I am presenting here my topic. Name of topic is the study of microphora of Rabi season associated with the groundnut field from Latur region, Maharashtra state, India. So here this abstract, yes, in the present investigation deals with the diversity of fungal spores in groundnut field. The aerobiological investigation carried out by using Tilak air sampler. Tilak air sampler to determine the groundnut field at Ausa region. The period of investigation was carried out from November 2017 to March 2018. Actually, the work was carried for one Rabi season. During the present investigation, total 38 fungal spores were trapped. Out of that, 4 were belongs to other groups. As this topic is related to the aerobiology takes into consideration the studies of all biologically significant materials that are transported in the atmosphere. The study of fungal spore is of great significance due to its role in the field of human allergy as well as plant diseases. According to the Agarwal MK, who has stated in the 1969, the present investigation deals with the Aerospora or groundnut field at Ausa region. Ausa is a taluka place in Latur district. Groundnut crop, however, continuously influences from various diseases, out of which fungal diseases are dominant, as the groundnut, which is Arachis hypogea, belongs to the family Fabaceae. As we know, India is one of the largest producer of oilseed crops in the world. Oilseed occupies an important position in the Indian agriculture economy. Present investigation focused on Aerospora over groundnut crop, and more stress has been given on fungal components of Aerospora. Here the materials and method which are used during the investigation. The aerobiological investigation was carried out by using Tilak air sample. The Tilak air sampler is an electric device. It contains rotating drum on which Sellotape of 1.5 centimeter width is fixed and on its non-stick end petroleum jelly is applied. It was installed in the middle of groundnut crop field at 1 meter height during the Rabi season from November 2017 to March 2018 at Ausa region. The apparatus was operated continuously for 24 hours every week for entire study period. After air sampling, the sellotape was removed and equally divided into 16 equal segments. Each piece of the tape thus obtained represents air sampling for 12 hours, day and night respectively. Each segment was mounted on clean glass slide with glycerin jelly, which is prepared in laboratory according to the composition given by Tilak ST, and covered with the cover slip. Scanning was done regularly. After the preparation under the 10x and 45x objective combination of binocular microscope. What are the results and discussion, or what are the results obtained? So the results and discussion, the present investigation in relation to general aerospora studies over groundnut field Arachis hypogelene was carried out for Rabi season from November 2017 to March 2018. Total 38 fungal spore types and other 4 types were recorded. It includes fungal fragments, insect parts, and pollen grains. During the investigation, it was and the cladosporium occurs throughout the year with highest concentration from November to December. Basidiospores and ascospore type were essentially wet weather spore type, and their seasonal maxima occurred during the November to January. Most of the conidial type like Urularia, Nigrospora, Alternaria, Sarcospora, and Iridospores were common throughout the season with higher concentration in the November month. The conidia of Tetrapola, Artenium, albugo, and spore of burn type occur in very low concentration and discontinuously with the no definite seasonal trend, but were conspicuous because of their size and shape. These are the photographs which I observed during the investigation. The first photograph indicating the late leaf spot which was observed on the groundnut crop. The positive
Madam, we are not unable to see your photographs. Just you give the information about is there any seasonal variation have you observed in the aerial microflora?
Yes, sir.
So what was that? What was
that
that variation?
Conclusion.
Yeah.
Among the isolated spores, some are pathogenic to groundnut, causes disease, and are responsible for considerable losses in yield of groundnut crop. The result obtained and conclusion drawn would definitely help in knowing the incidences of diseases and enable to serve as a basis for the devising disease forecasting system leading to the efficient control to the diseases. The incidences of pathogenic spores noted in the present studies is also considerable help to farmers and cultivator, as it would serve the purpose of alarming the likely occurrence of fungal diseases so that they can plan for the proper preventive measures beforehand. So, if we will compare about the meteorological conditions such as relative humidity, rainfall, and wind, these factors may play a major role in the release of fungal spores and eventually affect the composition of airborne microbes quantitatively and qualitatively. The maximum spore load in the air in Rabi crop season was due to the availability of suitable substrate. So, these are the references which are used during the investigation. At last, thank you.
Okay. Anybody want to ask question? Rabi microflora variation in groundnut field from Latur region. Okay. In Latur region, groundnut crop is taken in a major area. Okay. So anybody from participants can ask question to Miss Ujjwala Gaikwad.
Yeah, I just wanted to ask one. Can I?
Yes.
Did you identify the fungi which you had taken? Because we could not see your screen, you can mention it, no? The names?
Yes, ma'am. Yes, identified by using the morphological characteristics such as the alternaria, helminthosporium, tetra.
Okay.
Yes.
What was the third one?
Helminthosporium, bipolaris,
okay.
tetrapolar, alternaria, Actually, 38 fungal spores were identified.
Okay, there is some audio problem. It's okay.
Okay, so now we will move on next presentation. Gaikwad Manoj Ashokrao. Are you there? Are you online, Mr. Gaikwad Manoj Ashokrao? Yes. Okay. Sheikh Dilawar Singh Sheikh. Next presenter, Sheikh Dilawar Singh Sheikh, Department of Botany from Rajapur. Sheikh Dilawar Singh. Sheikh Dilawar Singh, okay. Avinash Bajrang Gurau. Mr. Avinash, are you online? Avinash Gurau, okay. Yeah.
Avinash Gurau.
You present your screen. Mr. Avinash, you can present your screen now. Mr. Avinash, mute yourself. Unmute yourself. Avinash raised his hand. So if you have some problem, then put your question in the chat box. Avinash Gurau. Okay. So I think there might be some technical problem. The voice, we are not getting voice of Mr. Avinash Gurau. Let's see. In coming time, we try to connect Mr. Avinash. Next, Dr. Savita Bajrang Wanikhede. Yeah. Dr. Savita Bajrang Wankhede. You present your screen. Dr. Savita Bajrang Wankhede. Yes, where your voice is not getting. You please unmute yourself.
अनमोट आहे नाही त्याच्यावरच करतोय आधी व्हॉइस वाढवा बरोबर चालू ए अरुण ये ना इकडे ते काय करायचं बघ
Yes, Dr. Savita Wankhede.
नाही आहेत ते सर आता सविता तरी काय झालं कळत some problem is there.
Yes, there is some problem I think in the connectivity.
Unmute themselves.
Yes. Now, okay.
Good afternoon, all of you.
Yes.
Good afternoon, all of you. Myself, Dr. Savita Wankhede. Today, I am presenting here mass multiplication of parvascular mycorrhizal fungi of vetiver zizinoids on Ilisuna corecana. Contains introduction, material, methods, result, discussion, references. Introduction, mycorrhiza. The term mycorrhiza coined by German botanist Frank in 1885. It shows the symbiotic relationship between plant root and fungi. Mycorrhiza means fungus and roots. Then types of mycorrhiza, there are two types of mycorrhiza, ectomycorrhiza and endomycorrhiza. In ectomycorrhiza, hyphae of the ectomycorrhizae, they do not penetrate inside the root cortex. And in endomycorrhizae, hyphae of the endomycorrhizae, they penetrate inside the arbuscle vesicle. It produces arbuscle vesicles. Then arbuscular mycorrhizal fungi is also called as vesicular arbuscular mycorrhizal fungi inside the cortical region of the root. Vesicles are used as storage organ and nutrient exchange stems zygomycota. Then the benefits of arbuscular and fruiting. It improves the enhancement of primary as well as secondary metabolites. It improves the soil structure and it also uptake the immobilized mineral ions including the phosphorus. Aims and objectives: mass multiplication of mixed and pure culture of arbuscular mycorrhizal fungi of vetiver.
I think there might be some technical problem in connectivity. Dr. Savita presentation of Dr. Savita Wankhede has got interrupted. Okay. Yes. Keep trying. Okay.
तुमच्याकडे आहे ना बाकीचं हे जर सोडून करा ना.
We are not getting your voice, Dr. Wankhede.
Okay, sir.
Yes.
Assessment of arbuscular mycorrhizal fungi by using this formula, that is percentage of mycorrhizal colonization is equal to the number of root segments colonized divided by total number of root segments examined into 100. Then mass multiplication of pure culture and mixed culture of arbuscular mycorrhizal fungi according to the Tavrashia and Khare. Results and discussion. This plate shows the mass multiplication of mixed culture and pure culture of arbuscular mycorrhizal fungi on Illucina corecana. This is the isolation of spore from rhizospheric soil of Illucina corecana. Glomus fasciculatum with subtending hyphae. It shows in figure AB, rounded shaped glomus reticulatum and glomus species, glomus fragilastatum and glomus citricola. All these spores were isolated from the rhizospheric soil of Illucina corecana. And then glomus mossy, ruptured wall of glomus macrocarpum, glomus globiforum, Eicolospora species and Eicolospora laevis were isolated from the rhizospheric soil of Illucina corecana. These are also Scutelospora pellicida, Scutelospora origlobosa, Scutelospora calospora and Gigaspora aureusea. All these spores are isolated from the rhizospheric soil of Illucina corecana. The plate fifth shows the root colonization of Illucina corecana. Coinocytic hyphae vesicles were observed in the root of Illucina corecana in the figure ABCD, and in figure F it shows the arbuscles observed in the whole mount root of Illucina corecana. Then root colonization of Illucina corecana in plate 6, it shows the magnified view of coinocytic hyphae oval shaped vesicles were observed in the mount of figure CDEF. Then also coinocytic hyphae. Then also coinocytic hyphae and vesicles were observed in the plate 7. In figure F, it shows the arbuscle, and in figure A, B, C, it is the vesicles, and this is thread-like structure is also called as the hyphae. Then mass multiplication of mixed culture and pure culture of arbuscular mycorrhizal fungi was done on Illucina corecana. Then root colonization was observed at 15 to 22 days, whereas sporulation was observed at 25 to 30 days. 95% root colonization was observed in Illucina corecana. Large-scale production of MF fungi culture was done by using mass multiplication. Prepared pure and mixed culture of mycorrhiza was used as a field and pot experiment in inoculum. It results concluded that the rapid and efficient AM fungal root colonization and high AM spore production was maximum observed in Illucina corecana. Large quantities of inoculum can be produced by pot culture technique. Therefore, the Illusiona coracana plant has been suggested as suitable host for the mass multiplication of AM fungi.
अरे तुम्ही रेडी आहात ना?
References.
हाँ. Join झाला का?
Dr. Wankhede, you presented very well. The topic of mass multiplication of mycorrhizal fungi. Now the session is open for discussion. If you have some problems or doubts, then you can ask to Dr. Savita Wankhede. Participants can ask doubts, questions if they have. Okay, I think there are no more questions. Next, Avinash Gurav. So, Avinash Gurav, are you online? Already he is unmuted.
चलो ठीक आहे आता नाही जाऊ ना बाबा सांग आपलं नाव घेतलं ना त्याने नाव घेतलं निघून गेलो.
Okay. Hello. Avinash Gurav. Yes.
Hi. Yes, sir. Present.
You share your screen. Avinash Gurav.
Screen are not present, sir. Orally, I presented the 2 papers.
So, from where you are talking from Kolhapur, no? I think.
Yes. I am talking from English in Sangli district.
Okay. So, are you presenting from your mobile or laptop?
Mobile, sir.
So, you can share your presentation from mobile also.
Presentation.
हॅलो सर तुम्ही काय करा आमच्या विद्यार्थी मनोज गायकवाड म्हणून विद्यार्थी त्याचं राहिले ना प्रेझेंटेशन.
हॅलो सर.
हॅलो
हॅलो मनोज गायकवाड.
मनोज गायकवाड. ओके.
Okay. I am the 2 papers are presented in
बोला ना.
यांचं होत्या प्रेझेंटेशन.
त्याचं झालं की आमच्या माझ्या स्टुडंटची.
हो ओके सर.
आपलं विद्यापीठ चालू बरं ठीक. आणि कशावर लिंक दिली
रिसर्च पेपर नेम इज
बरं हो मला
अविनाश can you share your screen, mobile screen?
No sir, directly oral sharing, directly oral presenting. Screens are hello
घेतली काय आपले बंधूचे. अरे वा.
Okay, so yeah, okay, go on speaking.
My project topic or research paper topic is the diversity of microfungi in Wasagde in district Sangli, and the present paper deals with the investigation of microfungi in village Wasagde.
Yes, go on speaking.
चालू करा ना तुमचं. Yes, you can start.
Mr. Avinash.
Yes. Okay. Directly Sangli.
In Sangli district, fungi.
Yes.
So your voice is not coming. We are unable to listen to you, Mr. Avinash. So there might be some connectivity issue. Okay. So you are visible, but your voice is not audible.
I think all the other participants should keep their audio on mute because still some are talking.
Yes. Other participants, you are requested to keep your audio mute. Avinash Kurav, you are visible, but your voice is not audible. There might be some connectivity issue. Okay. So, okay, you keep on trying. Okay. Next, Mr. Gaikwad Manoj Ashok Rao.
Hello.
Gaikwad Manoj Ashok Rao. Yes.
Yes, sir. I am here. Sir.
Yeah. You share your screen.
Sir, I am not able to share my screen, sir. I am present orally, sir.
But how you are going to present orally? You should supposed to share your screen so that your work will be visible to all. No.
Sir, there is a technical problem, sir.
You are visible. Your work should also be visible, no, to all. Okay.
Okay. Hello. Can I proceed, sir?
You present your presentation.
Okay, sir.
Manoj Gaikwad.
Yes, sir, I am listening to you, sir. Share.
So we are in the session of oral presentation.
Yes, sir.
Go ahead.
Okay, sir. So, first of all, I am welcome to all of you. And my research topic is an investigation of aeromicroflora with the help of Petri plate exposure method over the field of tomato crop from Latur, district Latur. So, tomato Solanum lycopersicum is an important commercial vegetable crop grown throughout the world, including tropical, subtropical, and temperate region. India is the largest producer of tomato next to China. Tomato is having outstanding nutritive value. It's used in raw or cooked and processed form, such as soaps, sauce, ketchups, preservatives, and pickles. Okay. It is a major source of vitamin A, B, and it also excellent source of vitamin C. Along with that, it also a good source of minerals like calcium, magnesium, zinc, potassium, and it also have a medicinal value. The pulp and juice is promoter of gastric secretion and blood purifier, and is considered as the intestinal antiseptic. So, an investigation of aeromicroflora over the field of tomato is it was conducted at the here Taluka Udgir, district Latur, in the Latur region. And to study this research, we used the Petri plate which contained the PDA media or the potato dextrose agar medium. And the present investigation is present investigation was carried out from June 2015 to October 2015 into the Kharif season. So there were total 14 types of fungal colonies and one unidentified fungal form were isolated. And the dominant species was Alternaria, Aspergillus, Cercospora, Fusarium, Rhizopus, Cladosporium. During the present investigation, Petri plate exposure method was used, and these results were correlate with the result obtained by the Tirak air sampler. And the fungal spores obtained by using Tirak air sampler show similar results with the Petri plate exposure method. The present study deals with the aeromicroflora over the tomato field at here. So during this present investigation, total 4 are isolated, and the material method is adopted for this Petri plate exposure. And the Petri plate contained the potato dextrose agar, and it is exposed in the tomato field for the 30 minutes at the 4 feet height from the sampling site at the 8 a.m. at the morning for regular 15 days interval during June 15 to October 15. And the Petri plate were incubated at 25 degrees centigrade for 6 days. And the total number of colonies appeared were counted for the calculation into the percentage contribution. Percentage contribution of individual species were calculated as per the standard formula. During the present investigation, aeromycoflora correlates with this Petri plate exposure method. 4 Petri plate contain potato dextrose agar medium used for the detection of fungi. And the percentage of fungal colonies were calculated by the formula, that is percentage contribution is equal to total number of colonies of one species divided by total number of colonies of a species into the 100. To supporting the air sampler with the help of Tierg air sampler, Petri plate exposure method was carried out. And it was observed that the fungal colonies such as Alternaria, Aspergillus, Rhizopus, Cercospora, Penicillium was obtained in the different percentage. So the percentage contribution of the fungal colonies as identified as Alternaria 8.1%, Aspergillus 8.1%, Barretaria 6.5, Cercospora 7.4, Chitomium 5.8, Cladosporium 6.9, Corularia 4.6, Fusarium 7.8, and Penicillium 6.5, Rhizopus 8.1. The maximum concentration of fungal colonies have been occurred during the rainy season. In these results, Ditromyces fungi such as Alternaria, Aspergillus, Penicillium, Cercospora were dominant among the isolated fungal colonies. Similar reports have been made by the Dower and the in 1991. शेयर किन करते हैं स्क्रीन शेयर करते हैं ना के hello
yes we are listening
सर स्क्रीन शेअर करता येईना गेले सर याच्यावर
हा म्हणून तर तुम्ही ओरली देतात ना तुमचा तो प्रॉब्लेम असल्यामुळे ओके
references सांगितले येऊ शकते so this is all about my work sir thank you
okay so participants can ask question to Mr. Manoj Gaikwad. So Manoj Gaikwad has done aerobiological survey of tomato field from Latur region, okay, by using Petri plate exposure method. So if you have some questions, doubt, then you can ask. So I would like to ask one question.
Okay, sir.
Okay, so have you observed any relation between the present air flora and the disease incidence in the tomato field?
Yes, sir. Yes. The result which is obtained by the Tierg air sampler is also similar with the Petri plate exposure method. While studying in the tomato field, so there is a presence of Alternaria spores, which causes the different diseases. For example, leaf spot of tomato, leaf spot of tomato, then the fusarium, which is caused the tomato diseases, that is fruit early blight in the tomato. So these spore is mainly responsible for the in the tomato crop in the early and the late season. At the time of flowering, at the time of sowing.
Alapure sir. Allapuri sir, are you online?
Yes, sir.
So if you want, you can ask question.
No, sir.
Okay. So thank you, Mr. Manoj Gaikwad. Now I
Thank you
will
very
call
much,
next participant. Again, so I will come towards the Avinash Guru. So have you solved your technical difficulty, Mr. Avinash?
Okay.
Still
Thank you, sir.
your yes. Okay. Still your voice is not coming. Okay. So Patil. Okay. No. Next participant is Mahesh Anand Avdhutrao Deshmukh. Mahesh Avdhutrao Deshmukh. Next participant Mahesh Avdhutrao Deshmukh. Are you online, Mahesh? Mr. Mahesh. I think Mahesh is not online. Next one is Minakshi Gajanan Pawar. The next one, Mr. Rohit Roshan Rai. Mr. Rohit Roshan Rai, are you online? Okay. Mr. G. Ramachandran. Mr. G. Ramachandran. Ramachandran. G. Ramachandran. Yeah. Yes. So we are not getting. Yes. Why? Voice is not getting. Mr. Rehna Mirza Sajid Beg, School of Life Sciences. Mr. Rehna Mirza Sajid Beg. Miss Rehna Mirza Sajid Beg. Okay, I will go to next participant. Mr. Sagar D. Paule. Palwe. Sagar. Okay. Mr. Kolle Ramesh Jnaneshwar. Mr. Kolle Ramesh Jnaneshwar.
Yes, sir. Yes, sir. I'm present here, sir.
Yeah. You present your skill.
So I will. Yes, sir. Okay, sir. Good afternoon, sir. Good afternoon, all of you, sir.
Good afternoon.
Okay, sir.
So make it full screen, your presentation.
Okay, sir. Sir, I am Ramesh Kolle. My topic is biofabrication and characterization of gold nanoparticle. Okay, sir. Biofabrication and the characterization of the gold nanoparticle and its anti-candida activity, sir. This is the abstract, sir. This study reports the biosynthesis of gold nanoparticle by the reduction of auric chloride by using the methanolic bark extract of tree Acacia leucofolia. It will be characterized by the UV visible spectroscopy, XRD, TEM, and the particle size analysis, which show that it below the 100 nanometer. So below the 100 nanometer in size. So it is a nanoparticle in nature, sir. In this study, we tested the inhibitory effect of gold nanoparticle on planktonic growth by the adhesion, biofilm formation, and the cell surface hydrophobicity. These are the virulence factor of the Candida albicans. When the in the immunocompromised patient, the Candida shows the candidiasis. Okay, in the gold nanoparticle, there is no cytotoxicity to the human up to RBC up to the 200 microgram per ml. So it is safe at even at the higher concentrations. Okay, introduction. The biosynthesis of gold nanoparticle, which was done using the various plant extract. These are the citrus lemon, citrus reticulata, which is already done. And Das et al. Reported the biological synthesis of gold nanoparticle using the bark extract of Abrama augusta L, which suggests that the polyphenol present in the bark extract, which is act as a reducing and the stabilizing agent. Here, the gold nanoparticle, it also inhibit the human pathogenic bacterial growth, that is a Staphylococcus bacillus. The nanoparticle, it also inhibit, it is already told, adhesion and the developing biofilm also, which is reported by the Yao et al. A recent study report the effect of gold nanoparticle on the biofilm formation of the Candida albicans, which show that the MIC value is the 63 microgram per ml against the biofilm formation. Here, the materials and method. The bark of Acacia leucofolia was collected from the SRT University campus, which was identified by Dr. Arya Mulani, Professor of Botany, School of Life Sciences. And this is the method which was followed for the extraction of the bark extract. Okay, methanolic extract we are using here. For the biosynthesis, we are using the 0.1 gram of methanolic extract. That is the 1% we are using for stabilizing and reducing agent for the synthesis of the gold nanoparticle. This is the method which I was following it. It will be standardized by me, sir. 3 millimolar, then 20 degrees centigrade in a 30 minutes. So within a 30 minutes, the synthesis of gold nanoparticle which is done. And the purification step was followed. Here we have purified the colloidal gold nanoparticle by using the centrifugation and washing with 3 times with distilled water and last time with the ethanol, and dried it at 60 degrees centigrade. And the dried powder, it is utilized for the anti-candida activity as well as for the characterization purposes, XRD, EDEX, SCM, TAM, and the FTIR. Here, the gold nanoparticle bark extract monitored. Okay, the characterization which was done by using the UV visible spectroscopy, which then XRD pattern, okay, which was done in the NCL and the FTIR, then EDEX, the gold nanoparticle bark extract monitored. Okay, the characterization which was done by using the UV visible spectroscopy, which then XRD pattern. Hello, sir. I'm audible, sir. Okay.
Yeah. Yes. Go ahead. Yeah.
Okay. The shape and the size of particle was measured using the TEA model in the Ruska lab of Hyderabad. Culture condition: the authentic culture of Candida albicans, which was obtained from the Institute of Medical Microbial Technology, Chandigarh, and the clinical isolate, which was collected from the Government Medical College, Nanded, which was maintained in the YPD. The planktonic growth of Candida albicans was studied using the standard microbial dilution method as per the clinical and the laboratory standard. Only one difference, only slight modification is there. Here we are using a spider media instead of the RPMI. Similarly, adhesion assay, which was done by the Raut et al. Then the biofilm formations by the Raut et al. And the cell surface hydrophobicity by Katware and the Karupal 2013. And statistical analysis by Bansode et al. Okay, this is the observations. This is the figure. Okay, this is the effect of extract concentration on the gold nanoparticle. As the extract concentration increases, the synthesis synthesis of the gold nanoparticle is also increases. This is the graph. This is the photograph. Okay, this is the aurichloride, and this is the colloidal gold solution, and this is the 1% of bark extract. Okay, this second figure, the UV visible spectroscopy of gold nanoparticle produced by the methanolic bark extract of Acacia leucophilia with increasing the molarity of gold nanoparticle. Here, the 3 millimolar, it is a good for the production of gold nanoparticle. Figure A, it is indicated that the effect of pH 4, it is a good. It gives a sharp peak as compared to the other peak. And the 20 degrees centigrade, it is a good. As the temperature is increases, the aggregation is also increases. So if you are increasing the temperature, the aggregation will be increases and the absorbance will be decreased here. This is the SEM picture, which shows that this is the SEM picture, which having the range 51 to 70 nanometer in size. This is the TEM images, which indicates that the size, it is a 46 nanometer in range. This is the XRD graph, which having the 4 peaks, which indicates that it is a crystalline in nature. This is the EDAX, which shows that it whatever the sample it is present, it having a gold element. Okay, this is the gold peak, which indicate that gold element it is present in this one. This is the FTR picture, which show that this is the gold nanoparticle, and this is the Acacia leucophilia extract graph, which indicates that polyphenol, phenolic compound, or other functional group, it is attached to that surfaces that are responsible for the stabilizing of nanoparticle. This is the particle size analysis, which having the size 71 nanometer in range. This is the zeta potential. The negative or a positive value indicates that the stability of the gold nanoparticle. Now, this is the anti-candida effect. The first graph, it will be show that as the concentration is increases, the planktonic growth of Candida albicans, it will be decreases. Here, this is the standard one. It is Candida albicans, and this is the clinical isolate. In the clinical isolate, there is a no effect. Figure 8, in A, the effect of nanoparticle on developing biofilm of Candida albicans. This is the standard one. Okay, as the concentration increases, there is a decreasing. There is an inhibition of the developing biofilm after 24 hours. Okay, here after the 48 hours, the developing biofilm is also decreases. This is the standard one, and this is the clinical isolate. At 200 concentration, this is the minimum MIC in the clinical isolate, in the standard one. This is the graph, a mature biofilm after the 48 hours of standard one, and this is the clinical isolate. From this figure, it is clearly indicate that the mature biofilm, it does not affect by the gold nanoparticle. Here, the adhesion, this is the standard one. As the concentration is increases, the adhesion is decreases. Here, there is no effect in a clinical isolate. The effect of gold nanoparticle on cell surface hydrophobicity of Candida albicans, this is the standard one. As the concentration is increases, the cell surface hydrophobicity is decreases. Is a percentage of cell surface hydrophobicity, it will be decreases. Here, the cytotoxic effect on a gold nanoparticle by using the human RBC, this is the standard one. Okay, at 200 concentration microgram per ml, there is no lysis of the RBC. This is the graph, the effect of nanoparticle on a developing biofilm of Candida albicans. This is the standard one after the 24 hour, show that at 200 microgram per ml, there is a 80% there is an inhibition is occur in case of the developing biofilm. At 50 gram, it show a MIC. At 48 hours, this is the standard one. Okay. At 200 microgram, it will show a 50%, more than 50% inhibitions. This is the SEM picture. This is the control one, and this is the treated one at 200 microgram per ml. Now, nanoparticles are well known for the antimicrobial efficacy.
Hello.
Yes, sir.
Yeah, go ahead.
Okay, sir. The nanoparticles are well known for their antimicrobial efficacy. The antibacterial activity of gold nanoparticle is widely reported. It is already known. Okay. The biological way of synthesis does not involve any in this study. The biological way of synthesis does not involve a toxic chemical, and this process is eco-friendly in nature. The bioprocess variables such as pH, incubation time, molarity, and the temperature, it will be standardized one. 30-minute incubation time, it is ideal for the synthesis of nanoparticle. Here, the scaling electron microscope show that ranges 51 to 71 nanometer in size, and TEM show that it is a spherical shape having a 46 nanometer. The XRD data, which indicate that it is a crystalline in nature having the 41 nanometer in size. This result indicate that stabilizing and the capping agent may increase the size of the gold nanoparticle. Das et al. Also reported the biological synthesis of gold nanoparticle Abrama augusta, which act the phenolic present in the bark extract, which act as a reducing and the stabilizing agent. The FTIR analysis indicate the presence of biological molecules on the nanoparticle, suggests that capping of gold nanoparticle. The zeta potential, whether it is a positive value or a negative value, it gives the stability of the gold nanoparticle. This study nanoparticle is in this way we have tested the efficacy of gold nanoparticle on the growth and different virulence factor of Candida albicans, and the biological synthesized gold nanoparticles show a inhibitory against the planktonic growth of Candida albicans, and the MIC was 50 microgram per ml. The mature biofilm are insensitive to the gold nanoparticle, and the clinical isolate and the standard one, it gives us some differences due to its strainal differences. Here, the hydrophobicity and the adhesion. Decrease the cell surface hydrophobicity on the treatment with the nanoparticle may contribute the inhibition of the adhesion. Okay. As the hemolytic gold nanoparticle are not advisable to treat the humans, we have studied the hemolytic properties of gold nanoparticle, and we find that the inhibitory concentration of nanoparticle did not inhibit the hemolytic properties. Okay, some study reported that the biofilm and the invasion are due to this factor. This hypothesis may be inhibitory activity of gold nanoparticle on Candida albicans may be due to the binding of gold nanoparticle to the extracellular hydroactivity enzymes such as secretory aspartyl protease. Okay, thank you.
Okay.
Some references.
Yes, very good, Mr. Ramesh.
Thank you, sir.
So you presented your work very nicely with a lot of supportive information from instrumental analysis. Okay.
Okay. Thank you, sir. Thank you, sir.
So really, it's very nice one. So if you have some questions, you can ask.
Yes. Yes, sir. Yes, sir.
Sir, I have a question.
Yeah.
Yes.
Who? Yes.
Sir, can you please explain in brief the principle of inhibition of biofilm by gold nanoparticles actually?
Actually, when
Ramesh.
Yes, sir. When the nanoparticle it having the very small in size, due to which the surface area it will be the increased one. When the particle is attached on the surface of that part on the yeast or Candida albicans, then what happened? It will inhibit some enzymes. The actual mechanism not known, but that hypothesis it will be done. So it will adhesion, it will reduce one, and the adhesion, it is a step in the virulence factor of the Candida albicans. If you are inhibiting the adhesion, then what happened? The candidiasis, it will automatically inhibit it one.
So okay, very well. The next participants now, Mr. Ramesh, you stop your screen share.
Yes, sir.
The next presenter is Meenakshi Gajanan Pawar. Okay. Just a minute. What happened here? Just a minute. No, okay. काय झालं?
पूर्ण कॉपी करून इथून ओके, इथं केलं. एंटर मार. काही
You share your screen.
फोन करू. सोळाचं करू का? 16चं करू. पहिले किती ठेवलं होतंस?
Other participants are requested to mute their audios. Only the participants can unmute themselves.
मी काय म्हणलो? हे असं MS Word मध्ये करू का?
Sir. आवाज येत नाही. Unmute yourself.
Hello.
Yes.
आता येते
Okay. Go ahead.
Hello.
Yes. Go ahead.
We have synthesized quantum dots from the Pinus rugibargi. Pinus rugibargi, it is a plant belonging to the Pinus family, which is about 131 feet and 40-meter height. It is evergreen. The needle from the dye.
1 minute, Mr. Kolia has unshared.
Yes.
Yeah. Mr. Kolia has to stop share his screen.
Ole, have you stopped your screen share?
Sir, it is already stopped, sir.
Okay.
There is some screen seen here about his comprehensive study, quantum dot.
This is the screen of another presenter. Next presenter.
Comprehensive study of quantum dots obtained from the Pinus roxburghi by green synthesis, its characterization and its antimicrobial applications. We have synthesized the quantum dots by, as this is the the plant were collected from the Mahabaleshwar region in the month of February. It was authenticated by Dr. R. M. Mulani. The quantum dots were synthesized by silver. 1 millimolar silver nitrated solution was prepared and 100 ml silver nitrate solution was titrated against the pinus needle extract. The color changed from pale yellow to the dark red wine color. Confirms the formation of quantum dots. The characterizations of quantum dots. The first confirmatory test was the UV visible spectroscopy. We have studied the UV spectroscopy. The peak was observed at 420 nanometers. This is the graph of this.
Madam, your screen is not changing, no?
Changing, sir?
It is not changing. Your screen is not changing.
This is actually the UV graph of this quantum dots, and this is the XRD pattern of this quantum dots. We have obtained the XRD. The peak were observed at 3844.
Your screen is stagnant. Once again, you share your screen. Yeah, go ahead.
These are the graphs of quantum dots. This is the UV analysis of quantum dots, and this is the XRD of these quantum dots. The peak was observed. Huh? The XRD, this is the XRD. The peak was, the graph was, obtained by drawing the intensity against the degree.
Madam, still, so your screen is not getting.
How my screen is.
Sir, 1 minute.
Control ticket.
Sorry. Once again, share the screen. Okay. Okay, your screen is not changing, no? Okay. Just go on speaking. Go on speaking.
This is the UV analysis. The peak was observed at 420 nanometer. These are the XRD of these quantum dots. The peak was observed at this at 38, 64, 77, Uh, these are related to Bragg's reflections of 111, 200, 220, 311, and 222. These peaks, these face-centered cubic phases, which are closely related to standard of Joint Committee on Powder Diffraction Standard. The sharp peaks confirm the synthesis of quantum dots, which are crystalline in nature. The next we have characterized for the same analysis. The same analysis show the size or the picture was like this. The irregular arrangement of this screen was observed of these quantum dots. It just visualized as like this. Then we have go for the time analysis. The time analysis shows the uh, size of the quantum dots. The size of the quantum dots was observed to be in the range of 40 to 100 nanometers. Then next we go for the uh, antimicrobial applications. We uh, we uh, we studied the antimicrobial activities of these prepared quantum dots, which was studied against E. coli and Bacillus subtilis and the P. aeruginosa. The best antibacterial activity was observed against the E. coli. The zone of inhibition was observed about 23 millimeters, and the zone of inhibition the zone of inhibition of the P. aeruginosa was observed about 17 millimeters. Then the conclusions. The green synthesis of from this study, we have observed that the antibacterial activity of these quantum dots was best against this E. coli, then this P. aeruginosa. The conclusion, the green synthesis of quantum dots was one of the most important methods for the synthesis of the nanoparticles. It was eco-friendly, easy to scale up, and one plus point of this method is that it does not give the poisonous chemicals which are generally used, means the other methods we use for the synthesis of these nanoparticles, which include these poisonous gases, which emit, the methods emits the light, heat, gases. These all disadvantages was avoided by this green synthesis method. Then as we know that these bacteria are showing good antibacterial activities.
Okay.
As this E. coli causes the ambiosis, we can use these quantum dots for water purification, as it is a good antibacterial agent. And we are also the P. aeruginosa also has shown that good antibacterial activity. As we know that the P. aeruginosa are infective against good, urinary tract infections, soft tissue infections, sepsis, bone and joint infections. All these infections can be avoided, means we can use these quantum dots for these to avoid this infection by using these quantum dots in lotions, creams and other pharmaceuticals products, so that this study can be useful in pharmaceutical industries and water purification.
Okay, okay. Thank you, madam. Next, Harvinder Kaur. Okay, you stop your screen share. Harvinder Kaur.
ना तुमचा हेडफोन चालला ना तुमचं ग्रीटिंग काय चालला
Dr. Harvinder Kaur from Bhatinda. Yes. Yeah.
Go ahead with madam. Yes.
Hello.
Yeah. Madam, make it full screen.
Okay. So the topic of my research paper is diversity of family Bolbitaceae from Punjab. First of all, introduction. The family Bolbitaceae can be differentiated from the other dark spored families by having usually rusty brown spore print and pilous cuticle, which is always hymeniform under the microscope. Satellacea is quite close to Bolbitaceae, but has black spore print, hyphal, epithelial, as well as hymeniform pilous cuticle is there in case of Satellacea family. And they are autodigesting corpophores present in this Satellacea family. During the various fungal forays from 2008 to 12, two genera, namely Bolbitius and Conocybe of family Bolbitiaceae, have been collected from different habitats of the state. The two species of Bolbitius, namely Bolbitius coprophilus and Bolbitius gladfeltri, have been worked out for their morphological and anatomical details. Out of these, Bolbitius gladfeltri is new record from India. Then 5 species of Conocybe mycorrhiza variety Tetraspora, Conocybe moseri, Conocybe zelenica, Conocybe lactea, and Conocybe intrusa were identified. Out of these, Conocybe intrusa, moseri, and Conocybe mycorrhiza variety Tetraspora, as well as Conocybe lactea are first time records for India. And this zelenica is first time report from North India. So these are the material and methods. First of all, collection of the mushrooms have been done from the different habitats, especially from the coprophilous area. Then their macroscopic characters were noted down according to the key to mushroom characters. And then spore deposit of these different collections have been done. Then drying and preservation of the carpophores. After this, microscopic observations have been noted down in the lab, and then identification of these mushrooms have been done by consulting different literature available. So this is the review of literature which have been done for the identification of these mushrooms. This area have been surveyed for the collection of various dark spored mushrooms along with which these Bolbitius and Conocybe genus have been collected. So these are the different habitats. This is coprophilous area from where this Bolbitius and Conocybe species have been collected. These are different areas, different views. So these Bolbitius and Conocybe of family Bolbitiaceae. First of all, I will present the first time record from India, the first Bolbitius gladfeltri. This carpophore have been found growing in the coprophilous habitat. This carpophore is with convex pileus and broadly ambonate center, and this is grayish in the center, and the stipe is axanulate and equal in diameter throughout. And the spores of the specimen, they are golden brown and they are double walled. Truncate jumpore is present on one side, and they are lens shape in under the microscope. This is the scanning electron micrograph of the obsidiospores, and almost 4 spored basidia are there, which are claviform in nature. Then these are the pileus cuticular elements, which are granular, and they are also columnar shaped, or we can say ovate in shape. And these are the chelocystidia. These are colocystidia, which are laginiform. And this is cross section through the pileus cuticle, which bear hymeniform pileus cuticular elements. This is cross section through the stipe cuticle, which show laginiform colocystidia upon the surface. This is Conocybe mycorrhiza variety Tetraspora collected from district Freeport. And these are different stages of this specimen. These are the young carpophores, and this is the mature one. In the young form, the pileus is bright in color. This is golden brown in color, and at maturity it get fades away. And in the young stage, the pileus is hymeniform. We can say the pileus is conical shape, and it attained conical shape in the mid of their growing stage. At maturity, it become convex. So the pileus margins, they have translucent striations along the periphery, and they get brittle at maturity. The spores are double-walled. They have a germ pore, and they are apiculate. These are the basidia, drawing of basidia, and this is colocystidae, which are lacetiform. This is the main feature of the conocyte, that chelocystidia, they are lacetiform, present in the at the gill edge. So this is cross section through the pilus cuticle, and this is the cross section through the stipe surface, which we are different kind of colocystidia there. This is scanning electromicrograph of basidiospores. So next is conocybe intrusa. This specimen also found growing in the dung area, and these are the two carpophores which are at their mature stages. So this is the line drawing of this specimen, conocybe intrusa. This is the scanning electromicrograph. This is the main feature, that is lacetiform chelocystidia present in this specimen. So this is conocybe lactea, which is also first time recovered from the Punjab state, and collected from district Ropar and Faridkot. And this is the line drawing of this specimen. So the results are that 4 above taxa, like Bolbitius gletfelteri, conocybe mycorrhiza, variety tetraspora, conocybe moseri, conocybe intrusa, worked out in the present study, are not earlier known from India, and hence have added to Indian list of agarics. Thank you.
So very good, Dr. Kaur.
Thank you, sir.
So if you have some questions, then you can ask.
Dr. Kaur, I had one question for you.
Yes, sir.
You have said that these are novel, the first time reported from India, but
yes,
I doubt. Have you gone for this molecular identification of this fungi?
No, sir. According to the available literature, that this species which we have collected does not resemble the literature that we have, only on the basis of their morphological and anatomical features.
Let me add that most often what happens in fungi, even nutrition changes the morphological forms. So if there is variation in nutrition, probably you may get some different morphological forms. So instead of just reaching a conclusion that there are new species,
no, these are not new. These are the first time records.
Okay, even though
I have not proposed these.
Even though whatever probably first time reports from India,
yeah,
whatever they are earlier, they are existing in maybe due to nutritional variation, they may be something in this form where you think that this could be. I suggest, it's my pure suggestion, that, why don't you go for molecular calling, either for 23 ITS or MATK gene or something like that.
Okay. I will try for the next time.
That will be more authentic for reporting that this is the first time.
Okay. Thank you, sir.
Okay, thank you, Dr. Harvinder Kaur.
Thank you so much.
Thank you for your presentation. Now, I will call the next presenter, Mr. Vittal Vaman Bhosle.
Yes, sir.
Mr. Vittal.
Can you hear me, sir?
Yes.
Hello, sir.
Dr. Kaur, you stop your screen share.
I'm trying to stop. Resume share? Or?
No, stop screen share. Stop screen share.
Stop sharing.
Stop screen share. I think it might be there on the top, no? It might be there on the top of the...
Yes.
Okay, please. Yes. Okay, now, Mr. Vittal Vaman Bhosle.
Yes, sir.
Yeah.
Yes, sir. Yes.
Present your screen.
Yes. Okay, sir. I'm sharing my screen.
Yeah.
सर शेअर करतोय.
You share your screen.
Just a minute, sir. Okay, sir. I'm sharing my screen. Sir, screen is not supported. The screen is not supported on the screen. I will present it orally.
Laptop or on mobile?
No, sir. I am on mobile.
Okay, try to share once. Otherwise, you speak on the topic what you are going to present.
1 minute, sir.
See on mobile.
Yeah.
On hello, Vittal. On mobile, you have on one corner above. You can share the screen.
Yeah.
I'm trying, but sir, they are saying that screen is not supported on that.
Okay, make your video audible, visible.
Screen share.
Okay, sir. 1 minute. 1 minute. Hello, sir. That's a problem.
Okay, so I will call next one.
Okay, so
Suhas.
I will call
Yeah.
next one.
Okay, go ahead.
Yeah. Okay, go ahead.
Vittal Bhosle.
Okay, sir.
Now you open your file.
You open your file.
Okay, sir. Can you see?
Not yet. Just you are sharing your screen, but the file is not open yet.
Okay. I'm not getting the option for that.
Yes.
You don't. Vittal, you are having range problem.
Okay, I think there might be some problem in connectivity. Okay, you stop your screen share. So I will call next person, next presenter, Suhas Pohare. Mr. Suhas Pohare.
Hello.
Suhas Pohare. Hi, Suhas Pohare.
Hi, yes, sir. I am ready.
Yes, present your screen.
Hi, yes, sir. 1 minute. Hello. Sir, I am presenting effect of nerol on cell surface hydrophobicity and adhesion of Candida albicans.
Okay, you present in nutshell because we are running very late, no?
Oh, okay. Sir, cell surface hydrophobicity, it is the one of the virulence factor of Candida albicans. If the more cell surface hydrophobicity, the adhesion also more. That's why I tried the modulate CSH of Candida albicans as well as GMC. GMC is a government medical college strain which is isolated from government medical college Nanded. I screened with neural on both Candida albicans and GMC. Okay, sir. On that CSH can Nerol inhibited CSH of Candida albicans, that is a standard strain 90028. It in a concentration dependent manner at 0.25 milligram mg per ml of nerol caused.
So you go on metal methods directly. Metal methods.
Okay.
Go on metal methods.
Materials methods culture one standard strain of Candida albicans ATCC 3017. It was obtained from the microbial type culture collection MTCC Institute of Microbial Technology Chandigarh, and GMC. It was also obtained from the Government Medical College Nanded, and these two strains were written on YPD agar at 4 degrees Celsius. Media and chemicals. The yeast peptone dextrose made by adding individual constituent like yeast extract 1% peptone and dextrose. These are the components dissolved in distilled water with pH 6.5 and sterilized autoclave, and that also PBS also there. That is the phosphate buffer saline, and it is made by monobasic and dibasic at a appropriate proportion. Okay, sir. Activation of culture, harvesting and washing cells. First, isolated single colonies from separated YPT agar plates of both Candida albicans and GMC3 were inoculated in 50 ml YPT broth in a conical flask. Then flask were incubated at 37 degree on an orbital shaker at 110 rpm for 24 hours. After that, cells from the activated culture were harvested by centrifugation at 5000 rpm for 5 minutes and washed with PBS with 3 times and again dissolved in PBS. I did the cell surface hydrophobicity by the math assay. It is but a slightly modification. Details of these two types of Candida cells done like firstly, single colony of Candida albicans and GMC3 were inoculated into different 50 ml of YPD broth and incubated for 24 hours separately. After the inoculated cells, broth were taken and did the cell washing process separately. Then the two beakers were taken and add 60 ml of PBS in both beaker and then add cells from stocks. Then OD means optical density was adjusted at 0.5 with help of spectrophotometer at 620 nanometers separately. Then the neural molecules I have screened against that both strain which is taken with their MIC concentration were taken added in a screw cap tube distributed in 10 ml cell suspension in two types of strains separately in 6 screw cap tubes.
Okay, go to result section.
Okay.
Go to result section.
Effect of nerol on CSH of Candida albicans and GMC3. Nerol inhibited CSH of Candida albicans ATCC 3017 in a concentration dependent manner at 0.25 mg per ml of nerol caused 67 inhibition of CSH compared to control, and in GMC nerol caused only 43% inhibition at concentration 0.25 mg per ml as a CS compared to control. It represent in graph. Also, effect of nerol on adhesion to treated as well as non-treated plate surface. Both strains that is first nerol treatment caused inhibition of adhesion to treated plate at 0.5 mg per ml caused 53 inhibition of adhesion. The nerol treatment caused inhibition of adhesion to non-treated plate at 0.25 mg per ml caused the 50% inhibition of adhesion of Candida albicans. In the GMC, nerol gave inhibition 21% only at a concentration 0.25 mg per ml on treated plate, while on non-treated plate it gives only 18% inhibition at 0.5 mg per ml nerol concentration. It is shown in the graph, sir.
Okay, go to conclusion.
Nerol inhibited cell surface hydrophobicity in a concentration dependent manner. Adhesion treated as well as non-treated plate were inhibited by nerol, but as compared to standard GMC strain, it doesn't show any significant results, sir.
Okay, so very good, Mr.
Okay,
Suhas.
thank you, sir. Okay, thank you, sir.
So participants, if you want to ask some questions, you can ask questions.
Yes, sir, I have.
Yeah, go ahead.
Sir, in this paper, I want to ask a question about the experimental concentration of nerol. Is it harmful to humans?
No, sir. Nerol actually, sir, in China, there is a use as a food preservative. That's why the nerol is not harmful for human body, sir. But at a higher concentration, it may be, but in a low concentration, it does not affect on our body, sir.
Thank you, sir.
Okay, now you stop screen share. Now, once again, I'll request Mr. Vittal Bhosle. Vittal Bhosle, are you online?
Yes, sir, I'm online.
Okay, you try to share screen.
Okay, sir, I'm trying. Just a minute, sir. It's not working yet.
So I will call names of some presenters. If they have joined late, then please be ready.
Yes, sir.
Yes.
Okay, sir.
Next,
Okay, sir. Okay.
Mr.
It is open.
Miss Rehna Mirza Sajid Beg. Again, Sagar D. Palve.
This is my screen?
Yes. Go ahead.
Hello, sir.
Yes.
This is Vittal Bhosle. Okay, sir. Hello, everyone. Myself, Vittal Vaman Bhosle, and I'm doing my PhD work in Department of Botany, Shivaji University, Kolhapur, under the guidance of Professor Dr. S.S. Kamble, sir. And today, I am presenting my research work entitled Influence of Physical Factors on the Growth of Pygeum verticillarius causing top rot of Bajra. Abstract: Bajra is a common millet that serves as poor man's food in India, Pakistan, and Africa. And top rot is one of the serious disease of Bajra, causing severe yield losses. In this study, the conditions suitable for the growth of Pygeum verticillarius causing top rot of Bajra were studied. The temperature, pH, and light play important role in the growth of Pygeum verticillarius. The optimum temperature for the growth of Pygeum verticillarius was 28 plus minus 2 degrees Celsius. The temperature 0 degrees Celsius, 5 degrees Celsius, and 40 degrees Celsius were inhibitory for the growth of Pygeum verticillarius, and the pH range from 3.5 to 9.5 all favored the growth of Pygeum verticillarius. In case of different light spectra, the normal light was suitable for the growth of Pygeum verticillarius, while no other light influenced the growth of Pygeum verticillarius as compared to the normal light. Introduction. Bajra is
material methods. Go material methods.
Okay, sir. Material methods. The disease samples of top rot of Bajra were collected from the different districts of Maharashtra and Karnataka, and the samples were brought to the laboratory, and they were cut into 3 to 4 mm pieces, and these pieces were superficially sterilized by 70% alcohol, and the cut pieces were placed on the Pectox agar medium amended with the streptomycin and incubated for 28 plus minus 2 degrees Celsius for 5 to 6 days. And the colonies that were observed on the plates were identified by following the monograph genus Pygeum by Muhammad et al. In total, 20 isolates of Pygeum verticillarius were obtained from these samples, and in vitro sensitivity of these samples were carried out by food poisoning technique given by Decker and Geiling. Isolate Fe16 was sensitive, and isolate Fe4 was most resistant and tolerated 60 ppm concentration of ROCO. And these both the sensitive and resistant isolates were subjected to the different temperature, pH, and different light spectra ranges. The plates containing sensitive and resistant isolates were wrapped with the gelatin papers of different colors, and their radial growth was recorded at regular intervals up to 8 days. CDF plates without any treatment served as control. This table 1 shows the result of minimum inhibitor concentration of ROCO against Fusarium verticillarius causing top rot of Bajra. The isolate FP4 from Metkorwadi was most resistant and tolerated 60 ppm concentration of ROCO, while the isolate FP16 from the D was sensitive and tolerated 20 ppm concentration of ROCO. These are the plots showing the result of resistant on sensitive isolate. 2 shows the effect temperature on radial mycelial growth of physical top rot of Bajra. Temperature and 0 degrees Celsius, 40 degrees Celsius were inhibitive for the growth of physical both for sensitive and resistant pathogen. You can clearly see that there is no growth of pathogen. Other temperatures regions moderately the growth of pathogen. The result of temperature. Table shows the effect of pH on radial growth of Fusarium from 3.5 to 9.5 were used. The sensitive slate showed the minimum growth at pH 0.5, while the resistant slate showed the minimum growth.
Yes. What happened? Yes. What happened?
घरीपासून जायच नाही वेळ आज विद्यापीठात काही असतील नेटवर्कच नाही ते चांगलं आहे पण नेटवर्क नाही त्यामुळे त्यांना काय समजणार बंद झाला तर ते
Yes. So your connection has lost. Okay. So I will call some other names. I think almost all participants have presented their research work. Rehna Mirza, Sajid Beg. Next one Sagar D. Palwe. Next one Sagar D. Palwe. Mr. Sagar, if you are online, then please present your screen. Next. Deshmukh Sajia Sultana. Umesh Mugle. Sachin Agrawal. Dr. Sachin Agrawal. Dr. Sharda Ulle. Mahesh Avdutrao Deshmukh. If anybody among these names is online, then he or she can share the screen and present their work.
Yes. Yes.
Hello.
Hello.
Yes, by anybody from
Yes,
the
by
list
anybody
is,
from the list is
wants to present. If you are not audible, then tomorrow in poster session
you can present.
Tomorrow we have one more session of poster presentation. In that you can also present.
So with this, we can we can stop over here for today's session. Tomorrow again in the morning we will meet at 9:30. 9:30. Yes. 10 we will start. Okay.
Thank you. I'm very much thankful to my co-observers here, Lapuri sir and Mirza sir. Thank you, sir, for being with us for this oral presentation. Mirza sir and Lapuri sir. Thank you.
Welcome, sir. Welcome.
Okay, thank you.
आजच थांबवून टाका तिकडून नाही चालत. येस हेलो हाँ बेग सर
बोलिए
बेग सर
जी सर बोलिए
हाँ आज का हो गया वी विल स्टॉप इट ओवर हियर
ओके सर
एंड टुमारो विल मीट एट 10 o'clock.
We are having
thank you.
presentation in the morning.
Yes, we will have a lecture session in the morning, guest lectures.
Okay.
And then after that we will have posters.
Sure, sir.
Followed by validatory function. Okay.
Okay, sir.
Thank you. Thank you very much. Thank you very much, everybody. We will meet tomorrow. Okay.
Leave the meeting. Somewhere here.